Josh Converse here in the back from WSU, who's been instrumental, and again, Lisa, Norm, and Felix from Earth and Spatial Sciences, and Seth and Evan have worked all together to bring this event to us. I think you've all been able to see the schedule of events online, and we have a pretty exciting day, hopefully, I think, lined up for you. We have 2 featured talks that really focus on some projects on the Palouse. We have one on the transportation theme starting in the afternoon, and then our first one here is going to be about water on the Palouse. Intermixed in there, a set of short talks on a variety of topics. So we'll hope you enjoy. We've got refreshments in the back. There's for folks who aren't familiar with this building, there is coffee upstairs you can purchase at Einstein's, food court out here. We do have restrooms right out here, and water fountains are available. So lunch will be pizza we have delivered. So if that suits your need, we'll have a lot of that coming at 11:30. But let's turn it over to Michael Pell now, who's Executive Director of the Palouse Basin Aquifer Committee. And his talk is titled Water Management on the Palouse Basin. And he works with cities, counties, and universities to ensure long-term quality water supply for the Palouse Basin region, which serves as the sole source of drinking water across portions of eastern Washington and northern Idaho. So he's going to do his presentation. We'll have a time for Q&A at the end. In person, we'll use the microphone for questions and answers so that folks online can hear. And for folks online, if you have questions, please put them in the Q&A for our Zoom moderator. With that, let's welcome Michael.
Bruce is taller than me.
Oh, yeah, right on.
Okay. So thanks for the invitation. I appreciate it. Okay. So I'll just use the, okay.
Yeah.
Got it. Okay. There I am. So I am Mike Pell. I'm the Executive Director of the Palouse Basin Aquifer Committee. I'm going to move this over here. So the Palouse Basin Aquifer Committee, who's ever heard of that? We call it PBAC. Has anybody ever heard of that? A few have. And I know there's folks online, so I'll try to provide enough explanation so you know what I'm talking about. So Palouse Basin Aquifer Committee, PBAC, is a partnership of the entities whose logos you see on the screen. So the Universities of Idaho and Washington State, the cities of Moscow and Pullman, Washington, Whitman County, Washington, and Latah County, Idaho. And then we have non-voting membership from the Idaho Department of Water Resources and Washington Department of Ecology. So the cities and universities, they're well, they're all the core. I'm not going to disrespect any of my member entities, but most of the water used in the Palouse Basin is from the cities and the universities. Okay, it's not really common for universities to have their own water systems, but we do here. So both UI and WSU have water systems. The counties do not have water treatment plants and pipelines all through the county, but residents of the counties rely on the same water, and it's all groundwater from aquifers that the cities and universities do. And then the state agencies are the regulatory agencies that control who gets to use water within the basin. So I thought, so this is GIS on the Palouse, and the Palouse, especially for folks online who may not be real familiar with the region, the Palouse is a geographical region that is not well defined. So this is from the Neal Public Library in the city of Pullman, and this is 3 different representations of the boundaries of the Palouse. And if you look online, you can see all kinds of different maps of what the Palouse is, but there's nothing that's generally accepted for what is the Palouse. So if there's a smart GIS person who can be persuasive and and help us move towards that, it might be a good thing, because we all know it's a geographic region in eastern Washington and northern Idaho, but we don't exactly know where it is. It's just a fact. But we do know is this is the Palouse. This is what it looks like. So when you're driving or flying or riding your bike or whatever around here and you see this, you know you're on the Palouse. So, but that's not even what I'm talking about, because the Palouse Basin is a subset of the Palouse. And the Palouse Basin is a confined area where our shared water supplies come from. So it's not all of the Palouse, it's just part of the Palouse. And I don't, is this point? Okay, here's the state line. And you'll notice that only a small part of the Palouse Basin is in the state of Idaho. Most of the basin, all of this other stuff over here, is in the state of Washington. However, about 40% of the water usage in the Palouse Basin is the smaller part that's in Idaho. Now, I know you're GIS folks, I get that. Does anybody know why more water than one would expect is used in Idaho than in Washington? Because this is actually pretty important to the regional economies and the geography. Anybody? Okay, I'll tell you. It's because we don't irrigate. And this is really important when we think about water management in this area. So this is a huge agricultural area. You cannot come here without noticing that. But it's all what's called dry land agriculture, so it's not irrigated. So the water usage in the Palouse Basin is municipal use. And when we talk about irrigation in the Palouse Basin, we're not talking about irrigating crops. We're talking about irrigating people's yards, playgrounds, parks, things like that. That's what irrigation is in the Palouse Basin. It's not the crops. So even though most of the land we don't use the water for that. So these are some artesian wells that used to exist in the city of Pullman, and this is why the cities of Moscow and Pullman are located where they are, is because even though this is a pretty dry place most of the year, there's a lot of water underneath us. So when the European settlers started to arrive and started drilling wells in the late 1800s in Moscow and Pullman both, there was so much water underground that it was actually pressurized. So the one on the right side of the screen was the big well in Pullman that for at least a few years was giving about 3 million gallons of water a day. The one on the top left is another. You can see the well drilling equipment, and they drilled a well, and here it came out of the ground like that. Well, we have on the lower left side of the screen, there's a little monument, a well memorial. I don't know what you call it, but there's a fountain where the big well used to be. Now here in Moscow, there were also artesian wells, but they weren't big gushers like that. But there was when they drilled wells, when they drilled a hole in the ground, the water came out of the ground. But as happens with pressurized things, that didn't last forever. And by the 1920s, most of the artesian wells were gone. But the towns were here, and the universities were here, and here we are to talk about that. So this is a cross-section of what's underneath us. And if you see, I've got to make sure I'm looking at it right. Okay, on the right side of the screen is Moscow, and then the left side of the screen to the west of us is Pullman. And you see the arrow coming down on the right. That is how most of the aquifer water was originally got there, and it's how it's even now being recharged and going back down into the aquifer. So there's what they call paleo channels, but places where water can get down into the aquifer. The brown layers are basalt layers, which water can't go through rocks. So we do have some issues with recharging the water. And this is, if anybody wants it, I see a picture. If anybody wants any of these slides, I'll provide them to you. But what I really want you to know from this is that there's not a big lake underneath us. Okay, it's a complicated geological system. Question? Okay. So the vertical lines that you'll see on the slide represent wells, and this is modeled from different parts. We can't send a drone down there. You know, all we can do is take samples in different places and say, okay, this kind of rock is here, and we hit water at this depth, and this is the best representation that we have of the aquifers. And by the way, there's two aquifers, and you see I'm pointing at my screen because I don't have a pointer to use. So the yellowish one is the shallow aquifer, and the greenish one is the deeper aquifer. The cities and universities right now are only using water from the deeper aquifer because the private wells in the counties they're usually not as deep. They might be 100 feet deep, 200 feet's a pretty deep one. And if the cities and universities use that water, the wells would go dry, and that's not being a good neighbor, is it? So what does PBAC do? Well, the first thing we do, the most basic thing that we do, is we pay attention to how much water we have, how much water we use, and how fast our aquifers are declining. Because sure enough, we're using more water than we receive every year. And we report on that. We work between the entities to understand our water usage and to comply with our groundwater management plan. We focus on water conservation, and I won't give Erin a shout out, but she's here. But we have really upped our focus on water conservation because we're going to run out of water eventually if we don't do that. And as far as return on investment, conserved water costs a whole less than imported water. We are funding a research project led by University of Idaho to try to figure out how to get more water into the aquifer. And we're also investigating importing water as a supplemental water supply. So let's talk about those things. So it's the same map of the aquifer basin that I showed earlier, except this one shows the locations of the wells that we monitor. And I need to redo this one because you shouldn't have, and you folks know more about this than I do, but it's clear when you look at it on a big screen that you shouldn't have little X's marking your spots that are the same color as the waterways. So don't do that. But the little blue X's are the deep wells that we monitor, and the little red X's are the shallow wells that we monitor. And when you monitor a well over time, you create a hydrograph. A hydrograph is a well level measured over time, and we have 30 years worth of hydrograph data for a lot of wells, and that's a outstanding data set. But what you'll see is that some of the hydrographs over time are kind of level, and some of the hydrographs over time are going down. And all of the shallow well hydrographs are doing okay over time. They go up and they go down, but they're doing okay over time. And all of the deep well hydrographs are declining over time. So we're using our water, like I said, faster than it's replenished. And this is a composite hydrograph of the deep wells that shows that sure enough we are running out of water. Now that's it's bad for two reasons. The first one is you need water and you don't want to run out of it. And the second is the way the state water laws are written. So we're here in Idaho, and the state of Idaho allocates water rights, and they say you can use water and you can have this much, and you can drill a well here and you can use this much water. But they can't say that to the state of, well, they could say that to the state of Washington, but they don't. And the state of Washington, same thing. So what would happen if the state of Idaho woke up tomorrow morning and said, Washington is stealing our water? Well, because they could. And states do fight about these things. So this is like kind of the essence in one way of thinking of what PBAC does is keep the states from fighting about our water management and work together on these things to not create that kind of tension. So one thing that we've been very successful on is helping folks conserve their water through awareness. And what this shows is that the cities of Moscow and Pullman have had population increases over the last several years, but our water usage has remained pretty constant. And that's because of awareness of conservation. And honestly, it's also because of government regulations. So low flow toilets, things like that, have become more common because there have been government programs to encourage that. But also, it's definitely true that if people understand the need for water conservation, they're going to be more likely to practice it. Now, this is the one that I keep wishing I had a better way to represent this. So this shows the water usage by the water pumping entities. So you've got the two cities and the two universities, and also the city of Palouse, which is our neighbor in Whitman County, smaller town. And this is, it's not really useful to compare entities directly, but it is useful to compare entities year over year. So if I had some kind of year over year pie chart, I need to think harder about that. But if I had a better way to represent, so if somebody's percentage goes down or it goes up just over 1 year or over 2 years, that doesn't mean too much, but over a trend over 10 or 15 years, that has a whole lot more meaning. Now, one thing that folks always notice is that how come University of Idaho uses so much less water than Washington State University? Does anybody know the answer to that one? Okay. You know, tell me.
I don't know. I was just wondering if it had anything to do with the golf course.
I'm going to answer that question, then I'll go to the golf course. Okay. So the University of Idaho uses recycled water that is treated wastewater provided by the city of Moscow for on-campus irrigation. So that means that in the summer, water usage does not go up at the University of Idaho. Or water extraction from the wells does not go up. In Washington State, they don't have that. Another thing, and I'll just be real honest, is that University of Idaho is really serious about water conservation, and they deserve credit for that. And And I think some of you folks were at the Water Summit a few weeks ago, and actually University of Idaho Sustainability Office received an award for their leadership in water conservation. That was well deserved. Since the golf course, the golf course question is always referring to the golf course at Washington State University. And when they proposed a golf course in the late 80s, early 90s, some folks said, you don't want to be building a golf course because golf courses take a lot of water, and we don't want to be using more water. So we've known for a long time that we were slowly running out of water. And this actually went to the United States Supreme Court because Washington State said, well, we want to build this golf course so badly that we're going to reduce water usage all across campus enough to offset it. And they did that. And it was determined, their final determination that yes, it's your water, and if you want to conserve somewhere else so that you can use more somewhere, you're allowed to do that. University of Idaho has a golf course too, and I've seen them both, and I promise you that the University of Idaho golf course is greener, receives more irrigation water, and it's what I don't play golf, but folks that do, they like to see that green grass stretching on forever. The Washington State golf course is a brown, dusty golf course in the summer, except for the greens. So yes, they do irrigate it, they do use water, and they do use groundwater that's not recycled. But that's there's other golf courses in the basin too. But the controversial one is in the city of Pullman. It's in Washington State, and there's definitely people who are still pretty sore about that, and that's their prerogative. So moving on, this is, I alluded a few minutes ago to a research project to determine areas of best passive aquifer recharge within the basin. And this is an ArcGIS project. Any ArcGIS people? Several, okay. So I think this would be pretty easy in ArcGIS. So we have the city of Moscow in the middle, that's the yellow. The brown zone is the area east of town that's geologically most promising for letting water go down into the aquifer. And then the green zone is the watershed that is where the water flows. So the areas where the green and the brown overlap are where we think the zones are where we can get water down into the aquifer better. And the little red dots are wells that we're hoping to sample. And this is, we're at an active recruitment phase of getting well owners who are willing to let us sample and see if we can learn about how old the water is in their well. And if the water in their well is very old, then it's not getting in there quickly. But if they have younger water in their well, then it would seem that they can use that area to potentially create better aquifer recharge. So here's some old school GIS stuff, but also to demonstrate that we've been working on this, or even before I'd ever even heard of the Palouse. This has been worked on for a long time to recognize that our well levels are going down, and what's the solution going to be. So the one on the left is a cover page from a study done in 1972 that was a proposal to import water from the Snake River near Hawaii. And the one on the right is a United States, they're actually both Army Corps of Engineers studies, but in 1989, it's 4 different proposed ways to import water to our area. And this is, so thank you, GIS people, for giving us better tools to work with and visualize than these, because this is literally what it used to be. And I've got to be honest, 1989, I remember when everything looked like this, okay? And I see a few gray heads in the room, and you know what I'm talking about. So thank you, GIS people. And then this is the big project that's happening right now. Move this up just a little bit. So right now we're proposing to potentially divert water from the Clearwater River near Lewiston, bring it to Moscow, and treat it in Moscow, and either inject water into the aquifer for aquifer recharge, or just use treated water from the river. This would also be shared across the state line with the city of Pullman and potentially Washington State. So I think that when the study advances, there's going to be a lot of GIS stuff. So when you somebody just joined. When you move up from the Clearwater River up here, there's potential cultural resources. There's potential ecologically sensitive areas that we would go through. There's definitely challenging terrain. It's well over 1,500 feet elevation change. So the different surveys and the different GIS information that will be necessary if this is ever to come to fruition is a pretty big need. So this is what we're looking at right now. Many things have been looked at in the past, and this is the most promising right now. So that's it. I covered a lot. Any questions?
Sure, this one's on.
Now, if you know anybody with a well that might be eligible, if you would send me a note at PBAC, PBAC at UIdaho, I'll get you in contact with the research team. Okay.
Questions in the room or online if you have them in the Q&A. Anybody in the room? A question here. A lot going on here, so here we go. Jen, hang on just a second.
Hi, thanks for the presentation. Can you elaborate on why it would make sense to, after transporting water up from the Clearwater, putting it back into the ground only to pump it back out?
The first thing would be that it's challenging from a regulatory standpoint to send water across the state line. So the state of Idaho would definitely have an opinion on sending water from Idaho into Washington. And if we sent water into the aquifer instead, that could potentially make that a non-issue. And there's also, I want to acknowledge, obviously, concerns with putting river water, even though treated river water, into a very clean, pristine aquifer system. One of the challenges would be potential failure of your system, and another one would be emerging contaminants that we don't know about yet. This is technology that is being used in other parts of Idaho and also other states. So it's been acceptable, and it's been found to be economically better. So even building a pipeline from here to Pullman is how many millions of dollars would that be? So there's a lot of answers to your question, but I think the economics and the regulatory might end up pushing in that direction. But we're absolutely not taking one side or the other at this point in time.
Okay.
Thanks for asking.
Yeah, and maybe a quick follow-up. Have there been studies of potential surface water storage?
Yeah, there's been a lot of studies of potential surface water storage. Even back in the day, Robinson Park, which is east of town, was a small reservoir at one point, so that's surface water storage. There's a proposal for a reservoir on Flanagan Creek, northeast of town, which would be surface water storage. But if we do go with the plan to divert water from the Clearwater, there's potential storage by the time all the engineering is done for that. And I don't know if that would be tanks or some kind of reservoir. So we're not that far yet. But you definitely got good thinking about what some of the challenges are going to be.
Thanks for the info.
Thank you.
Evan, you got one?
When you said looking at those places where you could improve recharge, what are the kind of projects that would actually, help divert water down into the?
I think it would probably be ponds. Probably ponds. Something, or swales. So maybe it wouldn't be a pond except, for a day or two. In other parts of the country that have different geography, you see a lot of what's called rain gardens. So just swales that water stands in when it rains, and then it soaks in better. So I think it would be some kind of system like that. And this is all private land, so it would also depend on cooperation of willing landowners.
Norm, do we have any questions online? Nothing online. Other folks in the room? Here we go.
Michael, do you know how the water moves through the deep aquifer? If you pump it into the ground in Moscow, is it even going to get to Pullman tomorrow?
I have the same question. The water moves, let me go back up here. So the water moves through the aquifer, especially the deep aquifer, very slowly. I've heard geologists say an inch a year. And I think exactly the speed would depend on where you were standing, because it's a complicated system. So I'm sure it moves more quickly some places and more slowly other places. But in general, it's a slow movement. So I would need to see more geological and engineering modeling. So if we put water into the ground on the west side of Moscow, how soon does it get to below Pullman? I don't know the answer to that, but that would be a question that we would need a better answer to before we would recommend that as a solution. So thanks for asking. That's a good question too. Good questions, guys.
Other folks? Seth? Yep, we got a couple minutes.
Hi, so I'm from the city of Palouse. I grew up there, and I was a bit surprised to see them on the pie chart over a place like maybe Colfax that has, I think, 2 or 3 times the population and a golf course and things like that. So I was just wondering if Palouse uses a disproportionate amount of water compared to their size, or if they were just on there as like an example.
Well, so the city of Palouse is on there because the city of Palouse has a water system and is within the basin. Colfax is not within the basin. So, and As far as disproportionate, I really discourage looking at something like per capita water use because a college town that has a bunch of people living in apartments is going to have lower per capita water usage than a town like Palouse, where most people live in houses and water their yards. The water usage has gone up for the city of Palouse because of the housing development that's gone on over the past few years. Does that answer your question? Okay.
Others? You got one here? Yep.
Okay, thank you. I see that in the hydrograph there is 0.7 feet per year decline of the deep water wells.
Yes.
So, did you think that the aquifer recharging is plenty enough to restore the declination of the water wells, or is there any other anticipated remedial action that you guys are thinking to rehabilitate this?
I continue to be impressed by the quality of questions. We do not expect that passive aquifer recharge will fix our decline. We think that there will need to be a combination of solutions. And so the three solutions that we're working on are passive aquifer recharge, conservation, more conservation, more conservation, and then as a last resort, which we think is going to be necessary, would be importing a supplemental water supply.
Sorry if I was actually missing. Is this due to the irrigation over-exploitation or just the effect of water supply as well that's declining the water level?
So the water is declining because we're using it, because we're pumping it out.
Yeah, for what? For irrigation or for water supply as well?
For municipal use.
All right.
So, yeah, and the irrigation that we're using it for is yards and parks, not for agricultural irrigation. Well, a park is, but commodity agriculture. It's municipal use.
Thank you.
Thank you.
Okay, I think we're at time. Mike, if you're able to stick around, some people might have other questions.
I'm going to stick around for
Okay.
a while.
Join me in thanking Michael for the presentation. Okay, that was excellent. We're going to transition to a series of short talks here. How many do we have? We have three? Three short talks here, and after those conclude, we will take a break. Let's go ahead and get those set up. We'll just be a minute or two here.
Hi everyone, thank you for coming. I know everyone's giving a little drink here in between. My name is Lisa Jones. I work in the Department of Plant Sciences, and I'm excited to help moderate our morning session of short talks. And our first speaker, I'm going to do my best to pronounce your name, Yesal Sapoznikov from the University of Idaho. So please come on up. Thank you.
Okay. Good morning, everybody. My name is Yesol. I'm a postdoc here at U of I in the School of Health and Medical Professions. I am so excited for this chance to talk about one of the many projects that are going on in our research office. So today, this project is about tackling Idaho's healthcare workforce needs. We are not GIS experts, so it's not going to be a very super technical, but you will see how we did data visualization using GIS tools as part of the analysis. Our research office is led by our director, Russell Baker, and the team consists of Madeline Casanova, Nicholas Coombs, who are joining us today remotely, and Christopher Godkin, right there, Cassandra Leonard, I don't think she's here yet, and myself. So this is a screenshot that I took from the Idaho Department of Health and Welfare. This is a snapshot of the dire situation we are in. As you know, Idaho is mostly rural state, as you can see in the map. Most of these counties in the state qualify as federally designated health professional shortage area, or HPSA. Rural patients already face many difficulties accessing care because of their remote location. Now this lack of providers exacerbate the problem so much worse. One of the initiatives to address this rural healthcare challenge is a program called Project ECHO, Extension for Community Health Outcomes. This is a program that was started in 2003 in New Mexico, and is based on a collaborative model of medical education and care management. It utilizes video conferencing technology such as Zoom to train, advise, and support primary care physicians, thereby increasing access to specialty treatment in rural and underserved areas. Over the years, the program has, Project ECHO has spread internationally, and you can see all these programs worldwide. In the United States alone, there are more than 1,000 programs out of more than 500 ECHO hubs. And we have one here in Idaho as well, called ECHO Idaho. And in fact, ECHO Idaho is the only ECHO hub in the state and is operated out of University of Idaho in Boise campus. And we here in Moscow, the Moscow team collaborates very closely with Boise team, and we provide various research and evaluation for the program. This is ECHO Idaho website. You can see these various programs, ECHO series on various topics ranging from heart failure, substance use disorders, dementias, oral health, and so on. And through this online portal, people can come in, create an account, register for ECHO sessions they're interested in, attend, and claim continuing education credits. And through this online portal, we go in and access all kinds of data for downstream analyses. So for this project, these were our objectives. First, characterize current and past participant demographics and enrollment patterns. Second, analyze regional characteristics to determine outreach targets. Ultimately, we want to assess how well or how successfully we are meeting the purpose of ECHO Idaho. This is the data we are working with. We downloaded enrollment data from April last year through August this year. It included a total of 151 sessions across 8 different series and 968 unique attendees. These data were downloaded as many CSV files from each ECHO session, and we used the Power BI to combine all these files and link to different other data from external sources and carry out the analysis. And the geospatial part of the analysis that you will see later were carried out using ArcGIS from within Power BI. So what did we find? First, participant characteristics. The first chart on your left, the bar chart shows you the breakdown of professions of our participants for each of the ECHO series. Overall, we saw there's a wide coverage of different professions, but what strikes out is the good chunk of participants are social workers, which is in pink. And the numbers for physicians, which is in green, and nurses in purple, are not as high as we would like them to be. When we looked at the cities that participants are coming from, the vast majority are coming from Boise and nearby cities. understandably, that's where all the medical centers are. And when we look at the organizations, there was a long list of different employers, but I listed here some of the major ones. St. Luke's Health System, based in Boise, was the #1 employer, followed by these major other health systems and agencies. Next, let's talk about maps. So Power BI offers several different GI tools within the software. I first experimented with Azure Map, but ended up switching to ArcGIS because I found that there were automatic features and just felt it was more friendly to beginners. So that's the screenshots you're seeing here. So the map on the left is just county level population in the state. And then on the right is the county level number of ECHO participants. The takeaway here is that our participants are concentrated in the counties with major cities. So you can see down there, Boise, the Ada County, has the largest concentration of the participants, and the neighboring Canyon County, where there's Nampa and Caldwell. Up north, that blue one, that's Kootenai County with Coeur d'Alene. Next, we focused on physicians. Our team had compiled physician workforce data for each county in the state, and they are represented, visualized in the first two maps there. First for overall physicians, and the middle one is for primary care physicians specifically. And then we brainstormed quite a bit how to most effectively combine the physician information with our ECHO participant data. And one way that we decided to try is to calculate the percentage of ECHO participating physicians out of the underlying number of physicians for each county. And that's what you're seeing on the right. So the counties with yellow, light yellow, beige color, those are areas where a very low proportion of physicians are participating in ECHO program, and we need to reach out more. But in identifying target areas, there are other criteria we need to consider. First, what counties have the best recruitment potential? So we can't just go out and try to recruit in all those beige areas. We want to also consider whether we want areas that have sufficient number of physicians already, like sufficient pool to recruit from. And of course, we want to target areas that could benefit the most from the program. So that would be areas lacking major health centers, lacking specialty care. So in consideration of these, this is very preliminary, but I highlighted these two broad regions, up north Panhandle area and down here southeastern area. So you can see those are areas have mixture of the beige color and the red color in consideration of these two. But again, this is preliminary and we are still working on this project. There will be more conversation, discussions going on with the entire team. So where do we go from here? With our findings from this project, hopefully we can target our marketing efforts in a more efficient way. And we also plan to carry out similar analyses for nursing and other allied health workforce data. And eventually, we hope to build a comprehensive healthcare workforce database for Idaho. So that concludes my presentation. Thank you very much for listening, and thank you to the organizers for this opportunity. Thank you.
Thank you. We're going to save any questions for the end of the session, so please stick around. Our next speaker is going to be presenting through Zoom. So if you can share our screen, it's going to be Sarah Olson from the University of Idaho.
Hi, good morning. I'll start sharing my screen. Okay, send a request. Um, I sent a request to share screen. I don't know if you have to approve it.
Yeah, I think we did hit the allow button, so maybe
Okay,
try again.
there we go.
Yeah.
Perfect. All right. Okay. Good morning, everyone. My name is Sarah Olson, and I'm a master's student studying water resources in the Department of Soil and Water Systems here at U of I. And I'm studying under Mariana Dobre and Aaron Brooks, and I listed some other collaborators from both Coeur d'Alene Tribe and the U of I down here. And I'm here to talk to you about some of my master's work, which is on a broader project with the Coeur d'Alene Tribe. And it's regarding using GIS and remote sensing to identify trends in crop productivity over time. So I think it's first important to contextualize why we're doing this research. A lot of environmental research in the inland Northwest circles back to salmon restoration, and that's one of the top priorities of the Coeur d'Alene Tribe specifically. So this picture on the right shows the first Chinook salmon returning to the Spokane River in over 100 years, which I think is pretty exciting. And so the tribe, a lot of the land cover on the reservation is agricultural, which can contribute to water quality issues through erosion and leaching of sediments and nutrients off the landscape from farms into the water. And this can impair salmon habitat. So where exactly do I tie in? The tribe wanted to target specific fields on the reservation to either improve conservation management and reduce erosion and water quality issues or remove them from production completely. So our main research question was, can we use remote sensing to identify like statistically significant trends and how certain crops or fields are performing, and how is that productivity changing over time? So our study site is in the Hangman Creek watershed, and the reservation is within the boundaries of the watershed. I have the outline here that you can see, and then I also zoomed out so you can see where it is in North Idaho and relative to Spokane. So essentially, the headwaters of the watershed are forested, steep fields in Idaho, and then the rivers in the watershed drain into the Spokane River. And again, some of those main water quality issues are related to agriculture. So things like suspended sediments in the water, nutrients like phosphorus, which are notorious for water quality problems, all that impair salmon habitat. So I'll explain some of our main hypotheses and assumptions. I know it's kind of word salad, but there's a figure on the right here if it's easier to follow. So our main underlying assumption is that crop productivity even varies across the watershed in the first place. So we needed some sort of variable that we could use as a proxy to assess crop productivity, and we selected evapotranspiration, which, if you're unfamiliar, is just the combination of water evaporating off the landscape combined with water that's transpiring from plants. And we're hypothesizing that it's a strong predictor of crop productivity. So following that logic, we hypothesized that fields with relatively low productivity will have low ET and exhibit poor soils. So that might mean things like the soils are hydric, they have poor water retention or shallow bedrock depth, etc. And then following that logic as well, these unproductive fields with poor soils should be targeted for either better conservation agricultural practices like reduced tillage or cover cropping, or maybe they should just be removed from production entirely. They might be disproportionately contributing to things like erosion and water quality problems, and they might just be less economically viable for the tribe. So first I'll describe some of our data sources, and then in the next slide I'll describe how we use them. So all of the evapotranspiration data that we acquired was through a Google Earth Engine script, and it's using a model called EE Metric, which was actually developed at the University of Idaho, so it's pretty well calibrated to the state. And all of this evapotranspiration data was assigned within the boundaries of individual farm fields. So on the right here, you can see the tool that we use to access the shape files that have our farm fields. And it's a project from the USDA called the Cropland Data Layer. They have data in both raster and shapefile format. And you can see here, this is a zoomed out picture of Idaho that shows land cover types. I selected an area that's near our study site, and you can see on the right here is just different land cover types throughout the year. So our specific study period was from 2008 to 2024, and that's how we accessed our shape files with land cover types. And then we also accessed any soils data for the project through a project called Surgo from the NRCS. And we did erosion modeling using a tool called WEP, which is the Water Erosion Prediction Project. So I think it's easiest to describe our methods using this figure on the right. So on the x-axis is the years of the study period, and then on the y-axis is average evapotranspiration in millimeters for a given year. So I think it's easiest to use this winter wheat figure here on the bottom right. So each of these lines represents the average amount of evapotranspiration for all of the winter wheat fields in the study area for a given year. And our statistical analysis essentially is finding relative ET for individual fields. So how can one field compare to this overall average? And how did we do that? So our Google Earth Engine script, it found the evapotranspiration in millimeters for each pixel within a farm field. We found the median from that number to represent each field, and that's what we used to compare with all of the other fields in the watershed. And we did this using a t-test for each field and finding a robust C-score, which essentially tells us, is this field statistically performing above or below average compared to other fields growing the same crop in the same year, and how often is it above or below that average? And then based on that statistical analysis, we grouped each field into different categories, whether they were consistently high or consistently low. So on the left here is one of the maps that we created using these categories, and this one is based on productivity. And one example takeaway that we can use from these figures is where are unproductive or productive fields clustered. So you can kind of see like that productive or unproductive fields are clustered together. In the headwaters, we might see consistently low fields because they're steep. There might be more erosion occurring. And then we also have other figures that exhibit different soil properties, and we have figures that model our erosion output, and that's both for specific crop types and individual fields. And that kind of describes how much they might be contributing to water quality problems. So why do I think that this research is significant, and what can it be used for? So first of all of our data is open source, which kind of removes an accessibility barrier for producers and farmers in terms of costs. And then yield or productivity is also historically pretty hard to quantify. It's difficult for producers to measure on the ground, and it's usually not publicly available for researchers to access. And I think this approach is also pretty novel in terms of how much data it can process and how quickly. So it can look into a pretty long historical period. And if you think about the amount of data, we have evapotranspiration values for each pixel in a pretty large image, also median values for each field. And then we have like over 1,000 fields within just one watershed. So using this large amount of data, we can pretty quickly analyze trends that are happening over time within a specific field. And we can also contextualize that field within a region, which is a super useful tool for producers to analyze their management or to see where there's certain water quality issues happening within a watershed. So what are our next steps? Based on our productivity analysis, we chose some soil sampling locations, which you can see in the yellow dots here in the watershed. And we just wanted to have some sort of physical data that we can use to examine relationships from our productivity analysis. So are the soils that we're analyzing in the lab right now that we took from our sampling, do they exhibit high organic matter, appropriate pH values, or nutrients, like just to validate what we've been doing. We also need some more robust measures to validate the remote sensing. Again, because yield data is so difficult to come by, we're thinking about repeating the analysis outside of the watershed where we have some concrete yield data that we can confirm our values. And the tribe is also working on procuring some more yield values that we can use. And we also need to take a closer look at our wet modeling. Eventually, once we analyze all these relationships, validate the data, we can prepare a comprehensive report for the Coeur d'Alene tribe, which they can use to target specific management. So whether they want to improve conservation measures for specific fields or just remove them from production. And with that, I'll wrap up. Here's some pictures of our field crew. Again, my name is Sarah Olson. I put my contact information up here if you have questions. And then some other good contacts are Mariana Dobre and Aaron Brooks, my advisors, and their contact information is there as well. Thank you.
Thank you, Sarah. If you can stay on for the rest of the session, we're going to take questions at the end. So our next speaker is also on Zoom. We have Gil Rezin from Washington State University.
Good morning. Can you hear me all right?
Yes, we can hear you.
Awesome. Yeah, let me go ahead and share my screen. It's this one. All right, then. So, as was said, my name is Gil Rezin. I'm an undergraduate computer science student at Washington State University, and I'd like to give a talk on something that is often overlooked within the field of GIS and computer science, yet has the potential to be transformative, which is the usage of large language models for urban modeling and planning. And what I'm going to talk about is a lot more abstract than what has been discussed thus far. This is a very novel field, and as such, there are many approaches that could be taken. But I'm going to go over preliminary research that I've done, as well as some other approaches that have been tested in this field thus far. So let's begin with some background context, some general challenges that urban planners deal with that can be felt by residents on a daily basis. Things such as managing the housing supply to manage the feel and affordability of communities, designing transportation systems that allow for the easy flow of people around said community, and maintaining amenities and infrastructure that allow for a high quality of life. Now, the main problem is that cities overall, they act very slowly. Urban planners are often planning far in the future, even as problems they need to deal with exist today. One case study of this is the Seattle area's Link Light Rail system, where the planning began in 1983, with construction starting in 2000, yet some of these lines, which were planned decades ago, are still yet to materialize. The connection from Bellevue to Seattle is only opening next year, and Tacoma is still not getting a rail connection until 10 years after that. And so urban planners, they will often work at a snail's pace compared to the pace of change within their cities. By contrast with their own plans, public pressure often results in redesigns, design modifications, or entire shifts in local plans. And while this can have a positive effect on the overall outcome of a project, this effect prolongs positive community change. In the example of the Link Light Rail, the initial proposal to Bellevue was struck down by voters in 1995, resulting in years of smaller transit projects in the region before finally obtaining voter approval in 2008. Were there to be better tools for guiding the public along with creating community plans, some of this friction between residents and planners would have been reduced, which ultimately brought me to my initial research question. Could there exist a mechanism by which new urban designs and proposals are quickly generated? More specifically, given what we know about generative AI and the way in which they quickly generate text or images, could that same process be applied to urban planning? Because if it can, we can speed up our planning and public input processes significantly, providing amenities in a more effective and more timely manner. So that began the basis for the preliminary research. Using pre-existing large language models, we can do a process known as fine-tuning, where you provide a model with lots of examples of how to do something, so that it should know how to do that task when given new examples. And so that was the plan. Essentially, give it lots of examples of what neighborhoods look like in a given space so that it can generate more in a blank example space. For the data set, as a proof of concept, I wanted to use a very small, easily accessible data set to build from. OpenStreetMap is the most easily accessible GIS data set available, so that's what I'm using. It even contains labeled neighborhood boundaries that I can use as examples. For example, these are all the neighborhood boundaries for Portland. And from here, I just built a simple script that obtains everything within these neighborhood boundaries and at what points there exist roads connecting in and out. To keep it simple, only road data was used in this data set, but the idea is that this can be scaled up to other urban data as well. Now, as we are tuning upon a model that's trained on text, we need a way to store our neighborhood data in text as a way that can then be converted back to geographic data to be displayed to the user. The solution to that was to treat features in a neighborhood as a set of shapes made up of coordinates that will be represented in the model. And so all these coordinates are normalized on a coordinate axis from 0 to 1. This is for, it's related to something in machine learning called overfitting, where the model will end up memorizing the shapes of neighborhoods and then will copy paste them instead of actually learning. And a similar process is done for things like augmentation, which is where you copy your existing data and then modify it slightly so that it actually learns the patterns. So in this upper image here, you can see the yellow is the neighborhood boundary, and then all of the pink lines are the roads that run in and out of the neighborhood. And as you can see in this bottom image here, this is an example of converting those coordinates to relative coordinates. So as you can see, each one has been converted on a scale from 0 to 1, representing the latitude and longitude relative within this box. Here's the overall data pipeline for this project. It takes in all the OpenStreetMap neighborhood coordinates from the boundary, as well as the connecting points and the overall road coordinates within the boundary. They're then converted into relative coordinates. Those coordinates then get augmented multiple times, and it's all put into one large training data set. There are about 1,000 unique neighborhoods within this training data set, but about 3,000 total when accounting for augmentation. And then the training data set is split up into a validation data set as well, and that goes into the overall large language model that I'm using. I'm using a low-powered Gemini large language model that I can run on my computer. That is then fine-tuned. The user then gives a prompt of a boundary, which then the large language model will generate coordinates inside of, which is then run through a script that is converted into a GPX file that can then be displayed to the user. And so here's how all of that looks in practice. This is a sample program that I created in which you can draw a boundary, hit enter, and then you get to see the example road shapes that get generated. Overall results were very promising. As I said before, this is a very low-powered large language model, so it's not exactly going to be generating the most complicated of shapes. But even with the relatively small data set for large language models, a few thousand is nothing in the world of machine learning. But overall, it was still able to form new patterns with the data it was given. And so as you can see here in this example, you can see all of the relative coordinates that are being generated up here from previous tests. And then when you hit enter, you can see all the new ones that get generated. Here's another example. The main thing of note in the errors of this are related to things that it wasn't given. Like, for example, the placement of housing. You can see sometimes it will cut through a house. That's because it just wasn't given that data. Or changes in topography. This is kind of a steep hill, but it wasn't given that data, so that's why it doesn't really conform to either. Which brings me into future research, because from this basis, we can begin adding more things to the model, like buildings, urban amenities, transportation. But it's from here that using larger models becomes necessary, in which you can't really run those models on a local computer. Hence why this research is only preliminary, and it's something to explore further. I would also like to begin labeling this dataset because it enables natural language prompts, such as build me a new proposal for a park surrounded by local shops, for example. And it allows for things like AI agents, where they have a chain of thought process that allows for a more comprehensive plan overall. And this brings me to the cutting edge of what other researchers, namely other computer scientists, are doing in this field with the help of urban planners. Some are taking a similar approach, which they're using transformer large language models as with AI agents, which make smarter decisions to generate the urban form. Like for example, in this proposed layout, they're using multiple AI agents, one for each individual task, where you draft constraints, urban layouts, and then one agent that actually evaluates the plans that are generated. And then there's another approach that involves using diffusion models, which are like the same models that are used in image generators, where they rapidly create urban plans from prompts. So like in this example, they're using several layers of data to fine-tune a diffusion model over a base map of an urban area. Regardless of what method is picked, in the same way that text and image creation has been changed with AI, so will the urban form. I'd like to end this presentation with a bit of food for thought. City LLMs within the field of GIS have implications far beyond academia. Because of their easy accessibility to others, proposals to local governments that may have only been possible to create with the help of a professional urban planner could now be done with anyone looking to make a difference in their community. Their vision of the community can now easily be created and demonstrated. The planning process becomes vastly more collaborative. It almost democratizes the tools of community change. To bring you back to that initial proposal for light rail connecting Seattle and Bellevue 30 years ago, if at both the planner and constituent level, there were easily accessible tools that could quickly envision a community's future for broader public transit, the way we conduct public input would be fundamentally different. It wouldn't be a one-way street, but it would be a two-way street, producing better outcomes quicker. And maybe the Seattle region could get light rail just a little bit quicker. Thank you.
Thank you, Gil. And we have some time, so I want to open it up for anybody's questions for any of the three speakers that we just heard from.
I got one in the back here. Let me get you a microphone. Hang on a second. So if people online can hear.
Hi, my question is for Sarah Olson, if she could go over the next steps with the Coeur d'Alene tribe again.
Yeah, do you want me to share my screen or is it okay if I just share my thoughts?
I think you can just share your thoughts.
Okay. So our next steps right now, we went out pretty recently to collect some soil samples and they're being processed right now. But we want to just look at those samples to see if the soil is validating what we think with our ET productivity analysis. So if our analysis indicated that a field is productive, does the soil look healthy? Is it exhibiting parameters that are conducive to crop health? Are those fields going to erode? So once we kind of illuminate some of these relationships, we can make some informed suggestions for the tribe. Essentially, like, do they want to remove some of those fields from production to either rewild them, support water quality goals, or change how they're managing them for agriculture? So things like reduced tillage. Does that answer your question?
He says yes. Any other questions?
Questions in the room? We have one here.
Okay, thank you, Sarah, for the nice presentation. I was curious how you guys pick up the ET as a proxy variable, because we have a lot of remote sensing proxy variables, or why not NDVI? Did you guys have a real concrete reason for that? And then the other thing is also, what is the resolution, the spatial resolution of your pixels? Did you think it is applicable for a fine resolution researchers like precision agriculture? Do you think it is really plausible to apply your methodology?
Yeah. So I'll answer your previous question first. So all of our data inputs were Landsat, which is 30-meter spatial resolution, which is pretty standard. I think it's not precision agriculture in terms of inputs like NAIP data sets where it's very, very fine, but it's pretty standard for management. And then the question of how did we choose evapotranspiration as our proxy variable instead of NDVI? We were trying to find some sort of like novelty for my thesis research specifically. So lots of research has been done on NDVI and other like vegetation indices and things. And there's been like maybe one or two studies on the Palouse that have used evapotranspiration successfully as a variable, but they were using it in combination with other things. They were like analyzing DEMs for topography data, and they also had on-the-ground yield monitors. So it's been kind of successfully proved before, but we wanted to explore it a little bit further. And we figured it says something a little bit more quantitative than NDVI does, because essentially all NDVI is greenness. And evapotranspiration is actually conditions on the ground. So how are plants responding? More productive crops are probably going to have more evapotranspiration. So that's why we selected it.
Okay, sounds like we have a question online. Is that correct? Okay.
Thank you. This question is from Allie Bean online for Sarah Olson. Are any of the sampling sites from the WSU R.J. Cook Agronomy Farm? They have collaborated with Aaron Brooks on projects from the USDA Long-Term Agroecosystem Research Network. Great research being done out there on comparing business as usual to a more conservation-based work.
Yeah, so all of our sampling sites were within the Hangman Creek watershed, which doesn't include Cook Farm, but we were thinking about trying to use data from Cook Farm to validate our results because they historically keep pretty good track of their yield. So we might be working with them. I know they have a good relationship with Aaron, so that data would be pretty easily accessible, but no, we haven't used it so far.
Okay.
Any last questions from anybody? Okay, well, I think it's time to take a 10-minute break. So we'll reconvene at 10:45, get some drinks, some snacks, use the restroom, and we'll get back together at 10:45. Thank you.
Thank you.
All right, everyone, let's get back together so we can continue with our next session of short talks. Our first speaker is going to be on Zoom. He is Phil Larkin from Avista.
Hi there. Thanks for having us. Really excited to talk about GIS at Avista, and thank you to the organizers of the event. Really appreciate the time you've put into this. So we're here to talk about GIS and wildfire resiliency. My name's Phil Larkin. I'm a GIS analyst supporting the group.
Good morning, everybody. My name is Matt Ugaldia. I am the Wildfire Resilience Manager at Avista.
So Avista has a kind of a long history of using GIS and using GIS in innovative ways. Early in the 90s, Avista started a CAD conversion, mass data to GIS. And then in the early 2000s, also worked on electric CAD to GIS. Some of the early pioneers of GIS at Avista recognized that innovation was needed to kind of overcome a gap in the geometric network offered by Esri, and ended up creating custom tools called the Vista Facility Manager and the Outage Management tool that help us utilize the geometric network and with more functionality. In the mid-2000s, Avista introduced field technology to gas programs, and our future focus now in the 2020s is to transition away from geometric networks and adopt Esri's utility network.
Yeah, so one of the other ways that we're really using GIS is in wildfire mitigation and prevention, which is a super important part of our business here at Avista. A little bit of context and background into that. In 2018, as I'm sure some of you are aware, there was a significant wildfire in California, the Camp Fire. That fire galvanized the utility industry and was a call to action to have mitigation plans and ways that utilities could safely operate and prevent the threat of wildfire. In 2020, Avista published its first wildfire management plan, and we broke that plan up into 4 key initiatives. And those initiatives are grid hardening, vegetation management, operations and response, and situational awareness, which is really where the GIS component of our plan lives. And so one of the key things in situational awareness that we developed using ArcGIS Experience Builder is kind of the nerve center of our situational awareness initiative. And this slide is a picture of our fire weather dashboard, and we've got a live view. We'll bring it up right now. And this dashboard, what it is it's a complex set of calculations and algorithms bringing in all sorts of layers of information that we use to really inform our decision making around how to safely operate our electrical grid during times of critical fire weather. There's a lot that's going on to this, but I use this during the fire season, which is typically from May till about October, to change the system protection settings and also inform decisions about public safety power shutoffs, or PSPS. So yeah, again, it's a really detailed system, but on the last slide, we'll bring that back up for you guys. Or actually, we have a slide with it, but it's accessible by QR code. We actually were published in an Esri magazine about the development of this, as we did it all in-house. Go ahead and bring that up. And it's a really detailed article, and it's fascinating, the power of GIS and how are we able to pull this all together and create such a powerful tool, which is really the cornerstone of all of our, again, decision making around how Avista prevents wildfire. And if you're interested in learning more about this, we've got the QR link to that article on screen now if you want to grab that and read it at your leisure. But yeah, this is only one of the ways that we use GIS in our wildfire mitigation plan and supporting our customers throughout the fire season.
So one pressure the group sees on a yearly basis is reporting out to different commissions about how wildfire has affected the system. So the group came to us to ask, how can we better approach this problem? How can we do a better job in reporting? So we built a kind of a notification system that just uses federal fire information, and we use a nightly automation to identify when fire perimeters are affecting our system, and then we document that in a spreadsheet that will be used at the end of the fire season to report out to commissions, but also send out an email alert that lets people know fires, say here, transmission line. And we're just using Experience Builder here in this case. In the email alert people get, there'll be reference to the fire in question, and they have filters and other tools to kind of cut up that data and do a deeper investigation if they need to. And so this helps the group kind of streamline operations in terms of reporting, and provides a tool for more in-depth review of the data. And at Avista, we use FME a lot for back-end processing. So got a screenshot there of kind of what that looks like. Yeah. touch on Pano?
Yeah. So another really interesting technique that's come to light for utilities and fire managers across the West is this concept of AI-powered fire detection cameras. And while this isn't specifically a GIS product that we use, we did work with our vendors to integrate our GIS layers, our system data layers, similar to that slide that you just saw, to where we can look at our lines in relation to the AI-powered cameras and understand at near real time how fires might be encroaching or impacting our decision or our facilities, and we're able to make quicker decisions based on that. We can also work with first responder fire agencies and provide safety for them, where if we know that they're mounting a large response to one of our facilities near one of our distribution lines or transmission lines, we can act quickly to get into contact with the fire managers and see if they require any assistance from us, including de-energizing that line so they can safely work around it during fire suppression activities.
So another way our team has helped addressing challenges that come to wildfire resiliency program is one app that was built for community resource operations continuity. So in the event of a power safety, public safety power shutoff, community resource centers will be activated to provide different resources for the community. And one tool that is needed in that is just to understand how a CRC is going to maintain power in those events. And so this tool helps users who are supporting the CRCs to look at what feeders are potentially affected in those areas. We're running a little bit out of time, so I'm not going to step through how that works. But yeah, so far it looks like this will be a helpful tool.
Yeah, in the future, we're looking to further our understanding of risk management, especially around our capital investments. We've worked with another third-party vendor to do a cost risk benefit analysis for us. And obviously with that, it's important to understand our risk geospatially. So we're able to integrate our rich data sets provided through our GIS network and teams into this model, and it's consumed, again, using AI engines for near real-time information on risk and where we should spend our money to mitigate it.
Once again, thank you. Really appreciate the opportunity to present, and yeah, we'll stay for Q&A after.
Thank you both. Our next speaker is Paul Reyes from the Idaho State Tax Commission.
Good morning, everybody. My name is Paul. I am an alumni of the University of Idaho, and I came back here after 15 years. It's been really a treat for me to be here and feel the energy of the university. So, show of hands. How many people here likes paying taxes, property taxes? All right, select the group. Good. How many people here knows that GIS is used for taxes? Oh wow. Okay, so it was mostly my thing. When I got this job, I was like, GIS for taxes? What's that? So now I'm the manager of the GIS group at the State Tax Commission, and it's been a journey. I'm pretty new. I'm just 6 months into the job, but I'm really liking it because my education, my prior experience has been always geared towards conservation projects, GIS applied to urban planning, and so, but thinking about taxes and GIS wasn't my first thought. So, this is this is our group. It's me and Jennifer and Josh. They are both GIS analysts, really experienced and really great team to work with. And Josh has like 4 years of experience into that, so he's like our go-to person for understanding this, how this works. But so for me, it has been really interesting to see how GIS can be applied for pretty much anything now. This is what the bulk of what we do. At the State Tax Commission, we work with layers to define the taxing districts in the state. So here, this is a little model that I put together to explain this. So, you know, like for any parcel, in any given parcel in the state, there might be different combinations of taxing districts that affect that parcel. And so what we do at the State Tax Commission is we work with the taxing authorities to keep track of those changes. So whenever there is an annexation or a change in the taxing districts, we map that out, and that affects how taxes are calculated for properties in the state, right? So there are some properties that have a combination of, in this case, you know, school districts, sewer districts, fire districts, and there are properties that have different combinations of that, and so these are called the taxing, the TCAs, taxing code areas. And so we keep track of the taxing districts, taxing code areas, and we make sure that this is accurate and that this is complete. This is a process that has been going on for several decades, and so now we are learning, you know, how to integrate processes that were designed in the 70s with the technology that we have now, and looking at the future things that we can implement too. Okay, so these are just 2 examples of the maps that we create we manage at the Tax Commission. This one here is a layer of all the taxing code areas that I was referring to before, and this one to your right is a map of the fire districts. So we keep you know, just as an example, but we keep the maps of fire districts, school districts, all the taxing districts that we have in the state, and then the overlay of those districts creates the taxing code areas. We also have a system, a website that allows customers to see their information as needed. So you know, you can use this website to enter some parameters on the information that you want to see, and then you can retrieve the legal descriptions, the ordinances that created or annexed some land to a taxing district, and the maps of that taxing district. So I think that's a system that is working really well, but I think that it can use, I think that it would be very helpful to make it spatially viewable. And so, you know, this is one of those examples that I was mentioning before where, you know, there's a system that has been designed, it's working, and maybe now integrating it with GIS might provide a better service to people. Some of most of the requests that we get at my office is, you know, like getting the history of the history of parcels or the history of districts, and so we are trying to modify this so that it can be automated, so that the history can be retrieved with a query automated, instead of just us going manually to search year by year, you know, if there has been any changes in the taxing districts. Another part of the work that we do at the Tax Commission is working with counties. We support right now 25 of the counties in Idaho, and we help host for them their parcels layers as web map applications. Parcel layers are super important for counties, and they have, I think that there is a ton of applications for parcels data, but right now it's mostly just used for assessing the value of properties. And so the counties send us their data sets, we updated their information, and then we serve it as web maps to the public so that the counties can have an easy way to relate to the public. This is a screenshot of the website that we created with the Experience Builder for the counties. So we were trying to, gather all their web maps into one place, because often enough, there are projects that go across county boundaries, and so we are trying to make it easier for people who are looking for information to find a resource of these data sets. Looking into the future, we want to start using multi-scale geographically weighted regression to do some of the analysis that the appraisers are doing right now. I'm still learning how this works. That's a super interesting process, but I think that there is a really good opportunity for us to use these models to help improve the metrics that they use for their appraisal processes. And so this is a great opportunity for me to delve more into how these models work and to find an application that hopefully will improve the processes that the county appraisals do in the state. The key takeaways that I wanted to give in this talk is, GIS it can benefit as any tool of using it properly, and one of the best ways I think that GIS can be used is if it's in collaboration. So the work that we do at the State Tax Commission it's really nice to be able to do the GIS work, but a huge part of the work that we do is reaching out to the counties and going out there and listening to them, understanding what their workflows are. Right now we are working with 25 of the counties because there are so many differences in the way that they manage things. So some of the counties have a ton of resources. They have amazing GIS shops with lots of money and lots of knowledge. And some other counties, they really are trying hard, but they don't have a GIS dedicated personnel in some cases, or in some cases there is opportunities for us to provide the expertise that we have and to put it to their service. And so collaboration, super important. The other thing is GIS, I think it's a super beneficial tool, and I am really grateful that that I'm working in an agency that is open to using this tool for finding new ways of doing things and making our processes more effective and also more visual, right? Like right now, like I showed before, like the tools that we have available for the public are working, but if we can put a special component to that, I think that there is a lot of value for that. And then there is opportunities for doing modeling and using advanced tools in GIS that haven't been used before. That I really value the opportunity to explore these tools and to see if they can be useful for the people that are working in this process of defining how taxes are created and how are distributed across the state. So thank you so much for the opportunity.
Thank you, Paul. Our next speaker is going to be Amanda Wood from Alta Science and Engineering.
Good morning. I'm Amanda with Alta Science and Engineering. We have an office here in Moscow, but I actually work out of the Kellogg office up north in Kootenai County. I'm presenting the statewide management plan that we're helping our partner Great West work on for Idaho State. It's a statewide materials management plan for solid waste infrastructure for the entire state of Idaho. My background is mainly in field operations support with GIS. I was with ESRI Tech Support back when it was ArcPad and ArcInfo a long time ago when things were a little more difficult with data dictionaries and things like that. I know some of you here are from back in those days and are familiar with that. And what I support now is mostly field operations, soil, water, habitat assessment, and kind of like Paul's presentation previously, I hadn't thought of it in terms of solid waste management, just something I didn't think of applying GIS for, and it's turning out to work really well for this project. Does anyone know what Swiffer is or familiar with this project? If you Google it, it's very complicated. You don't really get what we're talking about. There's a lot of other things that come up. This has been one of the major problems or challenges with this project is getting the information out about Swiffer. It's solid waste infrastructure for recycling is the program that DEQ provides a grant for. EPA is a federally funded grant, and Idaho DEQ applied for this grant and they were accepted. And so we're partnering with Idaho Solid Waste Association to use this money to determine where we need more recycle facilities, solid waste facilities. So the grant overview, the main purpose of the grant is to collect data to determine where more facilities are needed for solid waste, something that I think a lot of us take for granted. I hadn't thought of it until I got put on this project, especially with the population growing in Idaho and then online shopping. One of our biggest challenges is cardboard, where to put cardboard. A lot of people don't know where to take their hazardous household waste. There's just a lot of education for people to understand where they can take these materials, especially as the population's growing here in the state. So the first goal of the project, there were no real regions for managing this type of data, so we went and used the Idaho district health regions. Some of you are probably familiar with that. I wasn't too familiar, but this is just, each of these districts has an office that we work with to get this information out for this project. So that's kind of how we decided to break down the data sets and work with each of these districts for community outreach and education for this project. So the first challenge was collecting this data. The types of materials that come in and out of these solid waste facilities, there's no metrics on it currently. There are at the individual facilities, but it's not consistent across facilities, so we weren't able to compare data as far as amounts of materials coming in and out of the facilities. So the phase one of this project, the primary goal was to create some sort of form or data collection tool that all the facilities could use to consistently to obtain a consistent data set across the state so that we could decide what to do with this data and where to potentially add more facilities. So when I first got put on this project, they sent me a really simple list of 12 or 13 questions that needed to be answered, and I made a survey 1, 2, 3 form that was super simple. But then once they got that draft, they came back with this decision tree that ended up being a lot more complicated than I had imagined. But this is kind of an example of why it's so difficult to track this type of data. A lot of things happen from the main facility to the secondary activities that they support as far as recycling or green waste or hazardous waste. There's just a lot of things that can happen. A lot of facilities don't have these secondary activities. And if they do, no one really knows where to go to drop off their hazardous waste or to recycle things. So this decision tree, Idaho Solid Waste Association came up with this decision tree that I had to then turn into a form that they could access through Experience Builder. So the facility manager or whoever was tasked with entering this data could click on their facility in Experience Builder, and the Survey 123 form is embedded in the Experience Builder, and they could fill this form out. The main point of this form, I think at some point there were 28 pages. If a facility has every type of activity occurring at that facility as far as recycling, in this middle section you can see some of the activities that occur at each facility. If a facility happens to participate in all those activities, the form can be quite long, and they didn't want, that was really discouraging for a lot of the data inputters to thumb through all these pages. So we made it very easy if a facility didn't participate in any of the given activities, they could easily skip those questions, and that made it more user-friendly, because that was the main challenge previously, was no one wanted to go through a 28-page form just to get one metric that we were trying to get out of them. So if you're familiar with Survey 123 and the data that kind of comes out of that, we're using those metrics to decide which facilities are participating in which activities, and kind of what metrics of materials are coming in and out. We don't have enough data right now, and this is kind of one of the things that we've discovered in this project. I think of the 128 solid waste facilities, only 48 have filled out this form so far, so we need a lot more data to figure out what's going on. That's one of our next challenges is public outreach and education as far as getting these facilities to participate in this survey. The public outreach part of this project is really key to making it successful, and our partners at Great West have gone out to a lot of these locations and have pop-up tents, just educating not only the community but the facility managers. And if that's any of you, please fill this out for us. We need more data. But Great West is the ones who have been going out getting this data for us, literally tracking these people down and saying, please fill this out. They have a lot of great information for the community as far as where the facilities are, but now we need the facilities to get involved and actually give us this data. So the main thing that we've discovered, there's huge gaps in the data gaps, not only the data we don't have, we don't know a lot of what's going on in some of these outlying facilities, and then just getting the community involved and also the stakeholders involved in providing us this information so that we can provide more facilities if needed. The team that I'm working with, there's several people from Great West, and then also ISWA, and then my project manager, John Munkers. They've been great in helping support this project and the use of Survey 123 and Experience Builder, and they have really been the ones driving getting this information out to people and getting our data set more complete. And that is it for me. Any questions? I'll be around later if you have questions. Thank you.
Thank you, Amanda. Is Dan here? Yes, okay. Our next speaker is Dan Cronin from Washington State University. I have pulled up your, using the web page, right?
Are you doing that? All right. Okay, good to see everybody, and thank you for the invite. So I'm going to start this presentation out a little bit differently. We're going to go in reverse. So firstly, let's thank our committee, our GIS Day committee, for putting this together. It's a huge amount of work, so thank you so much. And the reason why I want to thank that, because I know a little bit what it takes. I served on this committee whenever I was formerly at University of Idaho, so thank you all so much for all the work you do. Now I'm on the other side of the road, and I'm not going to show bias because we're all here for the same reason, which is this thing called Project 615. Has anybody heard the origin of GIS before? So back in the day, they used to have this font, right, that everyone was familiar with GIS because they referred to it as Project 615 because of the font looked like the letters 615. So in the 70s, they were like, wait, what's this secret kind of project that's going on? But it was actually just GIS. So font matters, so make sure you're choosing the correct font. Okay, let's jump into this. If you're interested, you can use, or I'll share this story map with you if you'd like to follow along. But usually what I do is I like to start out all of my presentations with a land acknowledgement. All of the projects here that I'll report on are paying homage to these particular tribes, the Nimipu here in Idaho, the Shoshone and the Bannock tribe and the Chauvin tribe, and then also the Onondaga or Onondaga in New York, in central New York. So we extend our gratitude to the indigenous people that call this place home since time immemorial. In our research, we recognize that it's our academic responsibility to build relationships with the indigenous people to ensure integrity of tribal voices. There's also this Native Land Digital. Has anybody seen this tool before? If you haven't, have a look at it. It's super useful, but it basically shows the treaties and then also the native lands of particular tribes throughout the world, not just the and first peoples around the world. And then collaborators for this project, we have, of course, the University of Idaho, the Center for Resilient Communities, some other universities here in our watershed, like Washington State University and New Rick. Let's see, so I'll kind of give a little bit of a background or rationale of where this project started and why we're doing it and why we're continuing to basically push this forward. So basically we have food production and emissions are causing this huge paradox. It's both a driver of change and then also a casualty. So that's something that we're using as the driver for this type of project. So as you all know, because of global greenhouse gas emissions and RCP values, those of you who are familiar with kind of the climate change or international interaugural panel for climate change models, these are driving some massive issues for water and atmospheric and then also land use. So basically, it's also causing some massive issues for crops. So we're seeing a huge depletion and projections in terms of the nutrients and the nutrient balance that's happening in all of our crops, not just here in Magic Valley, but this is kind of where we started to see the impacts with an NSF-funded project. So we saw a huge decrease in population, projected losses for nutrient depletion for zinc, protein, and iron. And it's mostly been affected for kind of a lot of the crops that we grow here in the inland Northwest: rice, potatoes, wheat, and legumes. So that's something of a driver and rationale of why we went through this study or performed this study. This started out in 2017 as a project with through NSF. It was a 5-year project to look at food, energy, and water systems and the solutions that came out of it. We ran an alternative futures project to our process to basically project out what the future might look like. We can't tell the future. If anybody in this room can predict the future, please come see me after the lecture. I have a job for you. But we run through forecasting tools with GIS and Esri tools, but also some other robust modeling tools that Clark Labs has created. So, and that was, driven by stakeholders, informed by stakeholders, and validated by stakeholders. So we had a lot of people in that project, including the tribes. After that 5-year project, I foolishly jumped over to the State University of New York in the College of Environmental Science and Forestry, easily the longest name for a college in the U.S. But with that came with this great opportunity to work with UNESCO. And UNESCO funded, and the Aberdeen Foundation funded this project to basically build an atlas of climate change for the Champlain-Adirondack region and the Frontenac Arch region. So basically our task was to look through the lens of the SDGs and create an atlas that could help out this notion of this area or this landmass called a biosphere reserve. Is anybody familiar with the biosphere reserves? A few of you. Basically, there are these, since the Man in Biosphere Reserve project from the 1970s, around 1972, was founded to basically protect certain areas and conserve different resources throughout the world. And it's another set of tools that we use for protection for conservation for these kind of areas. So basically, we started out the project looking at vulnerability mapping driven by stakeholders and the people of the place to understand what kind of criteria we could look at for analyzing conditions of some massive issues that could happen in the future. And that's it was really difficult to make this process happen because we were stitching together Canadian data and then also data from Champlain Adirondacks. I'm just going to blame this on the story map. This is not the laptop. This is the story map. It's just there's a bit of lag time. But basically, we used visualizations to illustrate the vulnerability and mapping, and then some of the areas that would have key impacts based on the criteria that stakeholders spelled out. We did this for Frontenac Arch and Champlain Adirondack region. And we also created a weighted raster overlay tool, which basically ran through stakeholder-defined assumptions of vulnerability, but also suitability. So say, for example, if there was a retrofit that needed to happen for culverts in an area in the Adirondacks. Around 2 years ago, they had a 100-year storm that flushed out all of these culverts and created a massive amount of erosion, but also some really huge stormwater issues. So you could use a tool like this, or stakeholders can use a weighted raster overlay to kind of choose their own adventure, to look at where there's going to be the most vulnerable areas for climate change impacts, or suitable areas for a retrofit, for example. So, you know, that creates a polygon, or excuse me, a raster as an output, and then from that you can create a polygon to define the area acreage of that area, but also send that polygon out to land managers. So UNESCO, for whatever reason, loved this project. They were really excited about it. They were, after funding, which we're currently writing a paper in Nature about, they invited us to the UN, to the UN ECE Council for Climate Action, or SDG 13, to present on this topic. And, you know, we basically gave the presentation, talked about the tool, talked about the atlas and the rationale, similar to what I just did in a nutshell. And then also they gave a call to basically produce the next version of that, tied to one or two of the SDGs, and in particular climate change and also food. So that's a bit of the rationale of why we're conducting this project. We're waiting on the UNESCO chair line to open up for more funding, but in the meantime, what we're doing is we're looking at defining food sheds. And basically this, I'll glean over this for sake of time, but basically food sheds have a lot of different definitions and have had a lot of different definitions over time. And our project here was to redefine or think about, instead of these static food shed boundaries, to redefine how they can look in the future with a lot of shifting, you know, anything from nutrient balance to proximity to drive time trade areas to some of these supply chain issues that we're starting to, or not starting to see, that we have been seeing. So kind of what we, or where we started with this is looking at the local scale. So you might be familiar with this particular watershed. Sorry for the lag time here, but basically we created a drive time trade area. Those of you are familiar with that tool, to not look at Euclidean distance, but to look at a proximity out from Moscow and Pullman to see what drive time looked like, but also walkability. And I'm not going to say which city has more of a food desert, but I will say it's a problem. And we need to start to address this quickly before it becomes an even huge food or larger food security problem. So that whole concept used atlasing, which is basically the framework or process to, or recipe to construct these kind of atlases to not only produce this future project that we'll go through, but also transferability into other projects that could help to define the biophysical conditions, the Bayesian belief network, which is basically how agents operate and move over space and time, and then also information from our subject matter experts, and then also knowledge holders. So the project basically looked at these various theme groups, so biophysical conditions, human capital in terms of labor to harvest, including migrant labor workers, aggregated to the county scale, so we weren't lifting the veil for obvious reasons, and then also supply chain conditions. And food markets. So basically we normalized all of that data and then enriched it with a large language model. At the time, this was from, so formerly called Twitter, now called X, but basically a lot of issues that people were responding to during COVID to say we're missing out on certain types of veg and or eggs and or poultry. We defined those theme groups, came up with a normalization for how those could be illustrated across the contiguous United States, and then put those into one weighted raster overlay and came up with these food shed boundaries as a redefinition. Lastly, we produced these indicators of where these areas as a weighted raster overlay would be impacted the most, and then used a geographically weighted regression to test if this was plausible or viable in terms of statistical significance. And this is kind of what we ended up with an output from our map. Our stakeholders validated it to say, yes, some of these areas are going to have some major impacts in the near future, so we need to start to rethink how the food sheds can be revisited. So in terms of scalability or broader impacts, it's basically in landscape ecology, nested hierarchy theory. Thinking about future projects at the site scale requires moving up in space and time to look at a regional aspect, right? A regional scale, but then also the global scale to train how that could work. So on the research side, that's kind of where we see broader impacts happening. On the education side, training up more folks who are interested in using Project 615, aka GIS, for their own work and innovations. And the innovation aspect, to use AI and hindcasting and forecasting to predict out what the future might look like. We're also working with some tribal nations. We're still waiting for the IRB to get processed, so I can't mention which specific tribes there are that are collaborating. But basically, we're looking at large language models coupled with scenario planning tools and digital twins to project out what future solutions, future scenarios would look like and the solutions to those particular scenarios. And then basically, the driver for all of this comes back full circle to look at the entire region of the Columbia River Basin for food insecurity, wildfire vulnerability, and then also water variability. The other component that's come out of this is a lot of dashboards where we're basically looking at student engagement, and this is kind of our litmus about the new innovators of these tools for the future for this particular project and initiative. Last but not least, this project has taken on a lot of different components and a lot of different aspects, but it does take a community to make that happen. So anytime you have the possibility to work with a group of researchers, practitioners, data managers, and GIS Day committee members, it's a lot more robust of a process to see this play out for next steps. And then last but not least, this is, working in conjunction with the Office of Tribal Relations and Native American Programs at WSU, and we're definitely open to thinking at the watershed scale, so we invite participants from our partners at University of Idaho if you're interested. Thank you for your time, and feel free to reach out if you have any questions. Thank you all.
Thank you, Dan. I'd like to open it up to the audience for any questions from the last 4 speakers that we heard from. Yeah.
This is just a small question for Dan, real quick. I was looking at one of the maps of, I think it was the food one, and you can see the state boundaries within it. Is that because just different reporting methods?
Yes.
Yeah, because you said it was like county level, right? So just, yeah.
So that was definitely kind of an issue. Well, not kind of an issue, but a major.
Viagra bros, or boys, or whatever they're called.
Phil, we can hear you.
Thanks, Phil, for answering that question. I appreciate that. Sorry. Yes, so definitely the county level boundaries and the prediction tools were up and had to be aggregated at the state level. So you had a lot of noise basically when we normalized things. So that was and it still is a major issue. Good eye, good catch.
Oh, we have a question online, I believe.
This is a question for Phil. I was just wondering, it seems like Avista has all this really incredible data. How do you manage to like share that data in emergency situations with, like fire responders and stuff like that? Because I'm assuming a lot of it's kind of company data, but you need to be able to share that in some platform or something like that.
Yeah, so I'll take that one. I'll turn our video back on. Yeah, so we've got quite a few different ways that we do that. A lot of our data currently is shared with shared service agreements, where we share bundles of information about our system to the first responders. We're actually, if we had more time, we could elaborate on all of the cool projects that we have. But one of the ones that is in the pipeline that we didn't discuss is this concept of, we call it the partner portal, where we have trusted partners, the emergency management groups, fire departments, local officials, water districts, critical infrastructure administrators, et cetera. And we're creating an online platform where we will host information and then share it out through like an NDA process at first. But it'll have all of our information, including our maps, the way that our system is currently configured, known fires, links to our cameras. We also have a big initiative where we're deploying our own weather network, weather station network. That information would also be available. With our GIS system as well.
We also have a program called Community Business Partners, where we share data on ArcGIS Online through a partner collaboration or through just group sharing. So if any of you out there think that we could collaborate and share data, just reach out and start that conversation.
Any other questions? Okay, well, I want to thank our speakers again from our morning talks. I think it really represented quite the broad range of uses and applications for GIS technology. I loved all the variety of the topics covered. So now we're going to break for lunch, and I hope everyone can join us for the afternoon session, which will start at 12:40.
We had an interesting discussion related to water here on the Palouse, and now we're going to transition over to talk some transportation on the Palouse. So GIS at the Crossroads, Building Data-Driven Freight Solutions for Pullman and Whitman County is the title of our next talk, and Melissa Cleveland and Cody Hodgins are here from Welch-Comer Engineering, so they're down from Coeur d'Alene to give us this presentation. And Melissa's senior project manager there with over 20 years of civil engineering experience, and Cody's a civil engineer GIS specialist with 5 years experience at Welch-Comer Engineering. So help me welcome them, and let's take a listen to this talk.
All right. see. Moving right along. So just real quick who we are. Welch Comer is a civil engineering firm, so we do everything from transportation to water and sewer type projects. We've been around a while, 46 years, and our offices are in Coeur d'Alene and Liberty Lake. We're a pretty small firm, 33 employees, and there we go. You already he introduced us, so I won't take any time up with that. Okay, our agenda today. So we are talking to you about this freight study that we did earlier this year for the Palouse Regional Transportation Planning Organization over in Whitman County. And so our agenda is to kind of go over the background and need for this project, talk about how GIS was the foundation for this freight study, the outreach, the public outreach, the alternatives development, and how we evaluated those alternatives and then what we ultimately recommended. You want me to? We had a lot of partners in this project. So the RTPO and WSDOT were the primary people in charge of it. WSDOT funded it, and the RTPO was leading it. But also the City of Pullman, Whitman County, the Port of Whitman, Moscow, Latah County, and ITD were all involved. The why. So Pullman was revitalized, the main street, in 2024. But it didn't change that this is the intersection of two state highways. So Main Street, Paradise, and Grand are all primary freight corridors. And so now that it's an engaging place to be in downtown Pullman and people are gathering in the plaza areas and eating out on sidewalks, it's difficult when you have that many trucks just continuing to roll through. So a thought, and the truck drivers don't want to come through downtown Pullman either. So the thought was, how do we improve the experience for everyone by giving freight alternatives? Our study area was pretty broad because we had to kind of figure out where are they coming from and where are they going so that we can connect point A to point B in a way that the truck drivers would actually use. Downtown is kind of defined as this smaller piece that's just kind of this area that's right downtown Grand, Main, and Paradise. So our goals, now if you've been in the area for a very long time, you'll know that this is a problem that has been studied many times before. This isn't something that's earth-shattering or groundbreaking. But our goal was to find something that's practical. And we took practical to mean it could be implemented relatively quickly and inexpensively. And that's always a relative term. So we took it to mean tens of millions of dollars instead of hundreds of millions of dollars. Some of the other alternatives are in the hundreds of millions of dollars, framework. So we did not want that. So we had the objectives of preserving downtown, identifying routes that met the industry, minimizing adverse impact to the surrounding area, leverage all this data that's out there. This has been studied a ton. So how do we grab all the data and use it, engage with the community, and support all of these local agencies so that they can go out into the world and seek funding. It also was a super quick schedule. So we got kicked off last year in mid-December, and we delivered the final report mid-June. So in 6 months, we just kind of sped through this whole thing. So moving along. So Cody's going to go over just kind of the foundation, how we found the data, what data we used, and how we boiled it down so that we could actually get something out of it.
Hello. All right, so yeah, just as Melissa stated, this was a super quick project, and so one of the ways that we were going to achieve that goals was to utilize existing data that was already out there. We didn't have a lot of time to really review, create our own data, analyze it. We had to kind of piggyback off of what was provided, what had been done, and what's available to everybody. So it really does start to kind of build the foundation of this project just using GIS by being able to employ all of that data really quickly and also being able to allow ourselves to visually see, some solutions here, but also, apply some GIS analysis to lead us to more informed decisions on what is a applicable, feasible route. So I'm not going to go over every single piece of data that we've looked at, but there is a ton that we got just that was publicly available for us. And that was all very useful in helping us make those informed decisions that I was kind of touching on. I'll go over a little bit of just kind of some public sources of data that we used. WashDOT and ITD, very invaluable, helping us map existing routes as well as future routes through the Pullman area, working with WSP, or Washington State Patrol, and LTAC, the Local Highway Technical Assistance Council over in Idaho, for some crash data. That'll lead us to, some improvements that are necessary for supporting some of these freight routes, as well as, looking at, are these routes that need improvements already today, to help us better understand what's necessary, what's applicable. City and county goes hand in hand in letting us know, like, hey, this is what we're planning for the future, for growth of our city and also growth for the county. So making sure that the freight route is, working in unison with already future planning was imperative. And then also looking at the environmental impact that a new freight road would be, or an existing road if improved upon, to streams and rivers, especially around here. Wanted to be cognizant of that and how that would impact. So the other thing we wanted to do was make sure that whatever we were analyzing was going to be an effective route, and we did that by looking at what the existing truck traffic looks like on some of these routes today, and finding a way to estimate how much truck traffic we could remove from the downtown area. That way we can get a measure of how effective this is and weight it, based on costs or other impacts that might be necessary to make it a good freight route. So we worked with Kittleson to do some of the vehicle estimating of how effective these routes will be, as well as analyzing what kind of truck traffic is driving through our area right now that we would like to accommodate. They use primarily a app called Replica, which allows you to set, some gates and monitor things like cell phones or signals, just kind of available data that Replica has licenses to, that really help us get a good picture of what traffic is looking like and how the roads are being used. Another thing that we used, which was kind of unique, was actually the Strava app, which isn't an engineering app. Maybe some of you guys have used this or use it. It's like a health and fitness app, but monitors users that are particularly interested in foot sports or bike sports. Not necessarily going to tell us the full picture of how many people are walking or biking on some of these roads, but will point us to where we'll probably be likely to find people using the roads this way. So that was pretty exciting. The other thing that we use, and like Melissa had kind of touched on, this is not groundbreaking research. This has been a question and a problem that has been tried to be solved over and over and over again through many past studies. So our goal, again, was just to find a nice, applicable, feasible, practical solution with steps to achieving these goals that the city can employ, because 20 years of planning and zero of action doesn't really amount to much. So we looked at many past studies and evaluated all of their applicability and feasibility across some of the metrics that we use GIS with to find a good solution, see which ones rose to the top, and create a plan for Whitman County. Overall, we got about 18 routes that we worked with stakeholders, as well as previous studies that we were having to analyze, and this is where GIS really came into play. Trying to analyze each route across this broad of a task and problem to solve. Using GIS was imperative to quickly compare and analyze and normalize some data to compare all of these different options and see which one is going to be the best fit.
Yeah, okay. So, and you guys can ask questions as we go, so we're not just talking at you if something comes up as I break the microphone. Okay. Okay, so just some key takeaways that we found as we walked through this project. Half of the freight traffic in downtown Pullman had a reason to be there. So we focused, they needed to be in that area for a delivery, or that's where they originated. So we focused on the other 50% because we couldn't move that traffic. They were going to be there anyway. So we focused on how do we get this other 50% to use a different route. We also knew, because we had done traffic studies for the Pullman Downtown project, that the freight peak hour was very different from the car peak hour. And I'll show you a slide that shows that. And the ag contributes to surges in traffic. So it's not necessarily in a lot of the traffic data that we have, because in the spring there's fertilizing going on, there's a whole bunch of deliveries for that. And then in the summer and fall is when they're harvesting everything. So there's another surge of ag-related trucks. So the numbers that we're going to show you are actually not the ag trucks, because there wasn't a good data source for that. So it's trucks in general, just knowing that in those surge times of year, it would be even more. And then the other thing is that there's a lot of other produce just kind of produced all over the Palouse, and a lot of that's going to the Port of Almota for various reasons. And so just looking at this kind of point A to point B, and I think I missed that a lot of the wheat and hay is actually originating in fields east of Moscow and coming through Moscow and Pullman on its way to the center of Washington State. So that was important to know too, and that really came out of those stakeholder interviews. So this is just the intersection of Main and Grand in downtown Pullman, and you can see I've kind of made it orange in the middle. The freight peak is mid-morning, and the vehicle peaks are, morning, kind of on either side of that, morning and evening. Part of that is that the truck drivers have gotten used to when they can get into downtown Pullman with the least amount of friction. So they've kind of found that this is the lowest traffic and this is when we're going to go there. But this was also important to have conversations with the public on some of these routes that we were showing them as alternatives, and them saying, oh, that route is already really busy. It's like, well, is it busy at this time of day? Or is it only busy at 5 p.m.? Because that's not necessarily when these freight deliveries are happening. These two slides, I think Cody was going to talk about them. We had all this data, and then how do you use it, right? You've just got all these data points. So his next slide is taking this data that he pulled out of a bunch of sources and making more of a heat map with it. So people could, the public and even us, could start to see where things were coming together and where we needed to get these trucks to and where they were coming from. Is that good enough? Okay. Do you want to talk about this one?
Talk about this. So kind of piggybacking off of those previous slides, we were also reviewing existing transportation studies that have happened that is adjacent to what we're doing as well. In this particular exhibit, this came from WashDOT's study for the Lower Snake River Dams Transportation Study. And as part of their task, they kind of looked at where freight was generally aiming to go. A lot of the product that farmers will yield, they'll store it in grain silos and then they'll move it over to a larger distributor to get over mainly towards, western state to, be shipped off wherever it needs to be. And this exhibit was helpful for us because it started to kind of coincide with what we were seeing data-wise, but also with stakeholder interviews, that the ports, specifically the barges kind of south of Pullman, are huge attractors for freight. The other kind of big movers over on the eastern side of Washington are primarily coming from the rail network, closer towards middle of Washington and Spokane. But kind of focusing in on our objective, which is keeping vehicles out of downtown Pullman, we're mainly interested in kind of that movement closer to downtown Pullman, which ends up being these ports. So it was just a little bit of a validation on our data as well as what we are hearing from people, that where people want to go is primarily to these ports to ship off their product.
This was just this isn't GIS. This was just a graphic that we had that was trying to explain all of this stuff that we were hearing from our stakeholders, that the wheat's kind of actually, wheat and hay are actually east of Moscow, and they're trying to go to the middle of the state, and then all the other produce is really kind of trying to go to the ports. And this is an oversimplification, obviously, but we were just trying to explain these concepts that we were learning in ways that the public could understand them. And then, what's next? Okay, the outreach. The outreach isn't really, part of this this conference that you're at, because it's not a ton GIS based, but the products that we developed were developed in GIS. So you want to just, yeah. So in a really short amount of time, we were able to personally connect with almost 150 people. So this occurred through advisory group meetings, one-on-one stakeholder interviews. We had a really well-attended open house, which we were shocked how many people attended that. And we did a ton of virtual outreach, because just today, in this day and age, people are most likely to find out about an open house or connect in that social media type environment. So we had a website, social media, which also was great because the other news outlets in the area would share our posts. And then we created videos. We had an introduction video that was a call to action so that people knew this study was coming and how they could be informed and involved. And then we had a summary video at the end that's just kind of the culmination of the study that we pushed out at the end. And we have it at the end of this presentation so we can show it.
I'd like to make a note.
Okay.
I will say, Melissa kind of underplayed the importance of the outreach here. A lot of the data as well as solutions that we had came from outreach. There's the people that are living here know kind of what they would like to see, and were really able to help us steer and find really great solutions, as well as point maybe shortcomings that GIS data that is publicly available, which has its limitations, might not tell us immediately. So definitely adds to the data.
So this was one of the graphics that we had at the first open house. And remember, we started in December, and then our open house was at the beginning of February. So that was super quick with the holidays and everything. And so at that point, we were explaining the why to them. They were saying that there's 1,500 trucks in downtown Pullman, not including ag trucks, just on a daily basis. That many trucks in downtown Pullman per day. Half of those need to be there. So we're focusing on this other 700 or 800 trucks. And then we also were explaining to them what we were learning from the data, that a lot of the data was east-west, like they were coming from, Moscow or even east of Moscow and going to the middle of the state, or snaking through Pullman and then going down to Almota. So a lot of this east-west traffic, most of it. And then we had this open house where we had all of the alternatives up on boards. We did, at this point, kind of, wade through with our advisory group and pull out some that were definitely not practical, but then we allowed the public to tell us everything that they wanted to tell us about these routes, and we got just a ton of feedback. And then, like I said before, we have a website. It's still up. You can go check it out. We had those videos, social media, newsletters that we pushed out like monthly, I think, and those actually had a really high open rate. You can track that. Press releases, and then the final summary video. We did that instead of having another open house, and that was partially because we had this hard deadline and also just the budget limitations. So it allowed us to kind of get the information out to everyone at the end without holding another open house. Okay. Okay, so now, are there any questions before we kind of get into the meat of the study? Yeah.
Did you make an effort to reach out to truck drivers?
Yeah.
Okay.
Yep, we did. Lots, and then also like the bigger ag companies would put us in touch with people that made like the ag deliveries, since the data that we had in replica and stuff did not capture the ag trucks. And the reason is that a lot of those ag trucks are independent truck drivers that just worked like during harvest, so they don't necessarily have the GPS recorders like in their cab, and that's where a lot of this data comes from. So we knew that we were missing this like sector by just using the data that was available. So we talked to a whole bunch of them, and our public involvement coordinator isn't here today, but she lives in Clarkston, and she's from the Palouse area, so the amount of people that she personally knew and could connect us to was really incredible. So I think that's how we were able to get through it so quickly and just talk to the right people. What else before we move on to this stuff that's not as much GIS related? Anything? Okay, so how do we narrow down the alternatives? So again, like WashDOT, when they gave the funding for this study, they were adamant that we needed to come up with practical solutions. There were some other solutions out there for decades that cost hundreds of millions of dollars, and just kind of a reality check, this area was never going to really secure that large of funding. And the area, the city, the county, and the community was never going to be able to generate that sum of money on their own. So they were, from the beginning, these need to be practical. So we looked, once we kind of boiled it down from the 18 to more like, 12, we were able to look at cost. We were able to look at, would these routes, do they already have load limited bridges? Which obviously we don't want to put hundreds of more trucks a day on bridges like that. What's the land use around these? You know, if it's ag or industrial, that's kind of great, but if it's residential, probably not so great. If it's the middle of Wazoo's campus, probably extra not great. So kind of looking at the compatibility, and then also looking at, I think Cody mentioned this before, just all the crash data that's out there. And I think he has another slide that goes more into detail on crashes. But we did all this overlay analysis using GIS, and then we were able to weight different criteria to get what solutions are kind of coming to the top. So these were what ended up being deemed the practical solutions. We still have all the other solutions on there, but these are ones that kind of met that criteria and warranted further evaluation. Ones that fell off the list were those really expensive ones, or ones that are a route that's now been developed into neighborhoods. So we're obviously not going to go mow down houses and put the freight route through there right now. So they just kind of came off the list. You're good?
All right. So I talked briefly about what kind of data that we use. Now I'll kind of go a little bit more into how we used it to make these informed decisions. And it's not anything super groundbreaking in terms of what GIS is capable of, but still really useful and important. I feel like a really nice, simple case of using GIS to help us come to conclusions and make decisions. So to start with, we were looking at bridges. Ultimately, we weighted a bunch of different criteria that we would care about when it comes to these freight studies to try and get to a point to where we would have a good understanding of what improvements are necessary for each of these routes to make a good, effective freight route. Bridges was obviously one of them. We used WashDOT and ITD available data, which luckily comes really attributed out with a lot of the bridge report data. And so we're able to pick and select the bridges along our practical routes really quickly using GIS and pull all the information that we've needed to know to determine if this is going to be an issue for a freight route, whether it's span length or the bridge deck width, the year it's built, or even the condition. If it already needs replaced, we're going to need to know about that for the freight study. So a lot of that publicly available data helped us complete that in a really quick, couple of minutes to checking out some data, able to check a lot of those factors off. The other thing too, stakeholders, but also just using like Google Maps, honestly, another GIS component that helped us just look for, perform a visual inspection on some of these bridges. And what we found was a lot of these, the data on, WashDOT's GIS data that they have doesn't say anything about load limits. So visually looking at the load limits posted on the road helped us also find like, hey, this bridge can't support the extra volume and capacity that we were proposing to use. So important to note when we're trying to choose a practical freight study or freight route. We also used crashes from documents from WSP. It's kind of exciting, maybe useful, maybe fun for you guys, is a lot of this data just came in Excel. It wasn't ever actually a point data. However, sifting through maybe like 150 rows, I was able to find some northing eastings on there and put it into a point data source. And from there, the analysis was very quick. Otherwise, you're digging through trying to find reference of each road and each row, whereas we were able to shorten that process really quickly using that northing easting data. And then at that point, we were able to weed it down even further by selecting crashes right next to, the practical routes that have floated closer to the top and been selected by the committee, as well as review some other things we wanted to filter out, like we're not particularly interested in crashes that aren't directly caused by the road. We want to get to the point to where we can see, okay, this is kind of a fault of maybe the design of the road versus this crash was caused by speeding in the winter. So filtering those out, being able to summarize that, and then also looking at the crash severity was important to us for this analysis. This is too big of a table to go over in one go, so I wanted to include it just because, not every crash is equal. A fender bender and a fatal collision is very different. And so trying to find a way to normalize a lot of this data was very important. And I chose crashes just because it was a larger database. I thought it'd be interesting to this crowd. But we normalized the data pretty much everywhere based off of what kind of volume it's experiencing now and how much we think it would be experiencing if we were to try to employ a freight route along this route. So using WashDOT's societal cost analysis is how we did it for the crash data here, which weirdly enough kind of associates a dollar cost for a crash, but is effective in at least telling us, hey, this crash is to this, has this kind of impact versus this crash is not as much. Using the county and city zoning as well, like Melissa kind of said, we wanted to make sure that these freight routes made sense, particularly in existing areas, but also in future areas. So reviewing where these freight routes coincide with future zoning was very important. We really don't want to put a truck route right through a school zone or, a residential area. And also, as much as we don't want that, we want the commercial and industrial areas to be able to blossom and be great with the support of a freight route right next to it. And so we had divvied up these freight routes and just took a percentage analysis of how much the freight route is in each zone. I don't think you're ever going to find the perfect route that coincides with exactly an industrial or commercial or even agricultural area, but we can get really close. So we took a look at that and weighted it based off of, just simply how much of the road occupies in what type of zone, and looked at making sure that those zones were the favorable zones. Those are just kind of 2, 3 maybe different weights or criteria that we wanted to base some of these routes on. This table kind of shows the summary of that analysis after we've normalized the data and reviewed it, and then started to just employ, like a number system. This ranked 1 and this ranked 4, and start to count it to let the data tell us exactly what are the routes that, based off of all of the criteria and different measures we wanted to weigh it against, what are the routes that are telling us, hey, these are the routes that we should focus on. And these 3 were the ones that floated to the top.
Okay, then the last part of the analysis was to make sure that truck drivers would use these routes. And so going in and again, focusing on that 50% that doesn't need to be in downtown, and digging into the data and understanding where they're coming from and where they're going. And look at what was called route competitiveness. So there was this analysis that was travel times between different gates. So we know that they're going to pass through this point and they're going to this point. And if our route connects those 2 dots, how much longer does it take to get to the same point using our new routes versus just going through downtown Pullman? So that's the simplest way to talk about it. So we created all these different routes. Our sub Kittleson did this part of the analysis. But we helped them by giving them all the routes and all of the distance data. And then basically of our 3 best routes, Bishop Boulevard, if you're familiar with that in downtown Pullman, it has the potential to shift 400 of those 700 or 800 trips that are non-agricultural freight daily. The reason for that is it's just closest to Pullman, so it captures the most amount of trips, and it gets people kind of right around where they need to be anyway. Sand Road, Kirkendall Road is a route that spans into Idaho, and it's expected to shift 250 non-agricultural trips. That one will be pretty important from an agricultural standpoint, again, with how the hay and wheat moves throughout the region. Albion, we found, won't shift too many trips, but it's still important because it's heavily used today, especially for agricultural trips, and there are issues on that road. There's a load-limited bridge, and there's a couple of intersections that are pretty dangerous. So that one stayed on the list, even if it's not, with the goal of shifting trips from downtown Pullman, it's still important to the freight network. And then I'll just go pretty quick on our recommendations here because I want to show the video and we're getting close to the end. But this is the Bishop route. We did look at all the intersections along there and how would they need to be widened to facilitate truck movements, what kind of signal timing and signal hardware upgrades would need to happen along there. Bishop is real steep if you've driven that, and so it's hard for the trucks to kind of, once they stop on the hill at a signal, it's hard to get going. So we recommended that they interconnect those signals so that they can sync up that network, so it's less likely that a truck has to stop. And then there's a bridge that probably needs to be replaced. And then the Sand Road Kirkendall route, that's pretty long, and it goes all the way, into Moscow. And there are several intersections that need improvement, turn lanes, just widening in general. A new bridge, because we'd be looking to kind of realign part of the road, and it would cross the creek in a different location and need a new bridge, replace a bridge, and then do widening kind of throughout. The Strava data plus our interaction with the public, a lot of people ride bikes on Sand Road, and not all of it has good, like, wide shoulders. So just widening kind of just to allow a place for those non-motorized users to be on the road if we're going to start putting 250 so more trucks a day on it. And then 2 intersections in Idaho, one at Highway 8 and then one at just a local road, to really kind of get all of this network to work. And then the Albion route, again, this doesn't divert a lot of trips, but we've kept hearing from the freight community that these 90-degree corners in the town of Albion were really difficult. And then there's a bridge right after that that's load limited, has been load limited forever. And then right at the intersection with the highway, it's very difficult to cross, and they're going to Almota, so they need to cross, and especially when Wazoo is, has a ton of students returning, and that kind of coincides with harvest. It's a real dangerous situation. So we were talking to WashDOT about putting in a control at that intersection. And then a real low-hanging fruit, the sight distance at Hamilton Hill Road and SR 194 is atrocious and could probably be handled like tomorrow. It's not that big of a deal to fix that situation. So then we just went through and the improvements are still expensive. They're not hundreds of millions of dollars, but they are tens of millions. And so we wanted to go through and break this up into pieces that the community could tackle. So we prioritize those for them. The immediate term are things that would make an immediate impact and are probably easy to either fund locally or would be really competitive for a grant. So those are several improvements on Bishop. Remember, that's the one that's going to divert the most trucks, so it meets our goal the fastest. Just some intersection improvements, signal upgrades, and there's some light poles really, really close to the road that, that bother the truck drivers. And then that sight distance thing on Albion. Near term, more improvements with the road structure on Bishop if we're going to put that many more trucks a day on it. And then starting to tackle Sand Road, Kirkendall Road with the intersection that needs to be realigned and the bridge, the new bridge that needs to go in, and turn lanes at the SR 195 highway. The medium term is replacing that bridge on Bishop, more on Sand Road with widening and just other safety improvements that need to happen, and the other intersections in Moscow, and then starting to tackle that stuff in Albion. And then long term, even more on Sand Road and more on Albion. Again, we're not diverting a lot of trips, so Albion isn't as important, but because we know it's important to the overall freight network, we wanted to keep that on the list. And then I guess we'll just show the video that was what we pushed out at the very end to kind of explain this whole quick, super quick project to the public. Do you want to, hopefully this all works.
Everyone has opinions about traffic. Whether you are currently stuck in bumper-to-bumper cars on the way to work, or you're just looking for a faster way to get to where you are going. We've all thought to ourselves, if they just changed these one or two things, everything would be better. But the fact is that unintended consequences are everywhere, and the solution that seems simple rarely is. That is why, when designing traffic solutions, it is essential that we make data-driven decisions that go beyond the surface and consider the broader picture of what is best for our community. That is why the Palouse Regional Transportation Planning Organization commissioned a study with funding from the Washington State Department of Transportation to find the best options for reducing truck traffic in downtown Pullman. Our team examined hundreds of points of data, explored dozens of potential traffic routes, and connected with nearly 150 local stakeholders and community members across a wide cross-section of industries. All with the goal of identifying practical solutions that could be funded and built by Whitman County or the City of Pullman in the next 1 to 10 years and beyond. We measured current traffic patterns and modeled where truck traffic is coming from and where it is going. And we considered the costs of dozens of scenarios, from simple sign changes on existing roads all the way up to new highway construction. Here is what we discovered. Of the truck traffic that passes through downtown, around 75% comes from the east and the west. Around half of the truck traffic in downtown Pullman is related to business inside the downtown district, which means that any changes we make to local truck routes will really only apply to the other 50% of freight traffic. We also learned that throughout the day, truck traffic tends to rise and fall at different times than regular traffic, with heavy vehicles preferring to cross downtown in the mid-morning and early afternoon, avoiding most rush hour traffic. The goal of the study is to point towards practical options that are straightforward to implement and within the reach of state and local resources. And no single project is going to accomplish everything at once. These routes are intended to be easier to implement, not necessarily replacing future needs for regional truck routes. So with that in mind, here are 3 strong routes that fit the study's criteria. The top practical route for alleviating heavy vehicle traffic in downtown is to improve Bishop Boulevard as the preferred west to east truck route. This could be done for approximately $7.65 million in improvements, mostly related to intersection and signal upgrades. Next, we have the Sand-Kirkendall route south of Pullman. The existing gravel road could be shifted south and upgraded to current standards, connecting to the Sand Road corridor all the way to the Idaho border. Finally, we have the Albion-Hamilton Hill route northwest of Pullman. By upgrading key streets, bridges, and highway intersections, this existing truck corridor could better support heavy vehicles with easier and safer access to Highway 195 and the Port of Almota. These and other recommendations are part of a report being submitted to the Palouse RTPO and the Washington State Department of Transportation. It will be up to state and local governments to decide whether or not to accept these recommendations and to find funding for construction. Each route will need additional study, engineering, and cost estimating before the respective government agency can move forward with construction. This isn't the last you'll hear about these projects, and there will be future opportunities to be involved in the process. To learn more about the specific recommendations and to dig deeper into the methodology and data supporting this analysis, read the full report at whitmantruckroutes.org.
Right. I think that's all of our time, unless anybody has just 1 or 2 questions.
Yeah, we got time for just 1 or 2.
So during the downtown construction project in Pullman, Bishop was the official truck route. Did you see any significant changes in traffic from that signage change in construction on Bishop?
Yeah, that's kind of why we knew that route works. And some of the improvements that we're recommending were the challenges with that route during construction. So we didn't change anything permanently as a part of that project. So I think that the signage that you're talking about would be to make people aware that this is a route around downtown. That doesn't exist today.
But you didn't get any data on how many trucks?
No, I wish we would have. All of them, right? Because they couldn't really come through downtown. But no, I really wish we didn't know this study was coming at that time. I wish that somebody would have taken some counts during that time, but nobody did.
Tyler, any questions online? Nothing online? Maybe one more if anybody has one, and then we probably got to move on. I have one quick one.
Yeah.
The work ITD is doing with 95 and Highway 8 and, taking input there, and how does that influence this or this influence that? Or are they mutually exclusive?
Yeah, we were working directly, with them. So we were staying in the loop with them and informing them of what we were coming up with and vice versa. Our study was super quick, and theirs is not. So our timelines did not align at all, but the city and ITD and the county in Idaho were also, heavily involved in the project. So, and I know that now the city of Moscow and Whitman County are working together on the Sand Road corridor. recognizing how important that is. But yeah, also those improvements, I think it was in our stakeholder meeting with the county and ITD that we first understood the importance of Sand Road going across the state line and up and into Moscow. So all of that kind of informed the decision making.
Okay, very good. Well, we've probably got to move on now. Join me in thanking Melissa and Cody.
Thank you, everyone.
Thank you. And if you have further questions, they might be around here for a little bit. And we're going to transition over to short talks, which we have for the next 20-25 minutes, and then we'll go into a short break before we do trivia with folks down south.
Are they in person? Okay, thank you. Good afternoon, everyone. This is Felix Lau. I'm a faculty member in Earth and Spatial Sciences. So now we are going to start the second Shock Talk session. The first Shock Talk comes from Everett Fractures from University of Idaho and Federic Namari. So they will talk about integrating GIS, LiDAR, and AI tools for quality of individual tree segmentation. Thank you.
All right. Thanks for coming in today, guys. This is a really great event. Let me get this going. So, yeah, my name is Ed Flathers, and I'm a research scientist at the College of Natural Resources here on campus. I work with a group called the Digital Forestry Lab, and more widely with a group called the Forest Innovations Institute. And what we try to do with our research is we tend to work a lot with remote sensing and forest data in ways that can help to improve or inform forest management decision making. So various people who need to make management decisions about forests for whatever management goals they happen to have. Sometimes these forests are production forests where they're going to harvest the trees and make them into lumber or something. Sometimes we're talking about management that's oriented toward wildlife or oriented toward like carbon monitoring and that kind of thing. So just a little bit of background there. And I'm going to talk about the pipeline that we're using right now to get some of our remote sensing data processed and turned into GIS data that can more easily be used for these decision-making types of goals. So in this case, what I'm going to talk about is a process that starts out with LiDAR data. These are 3D point data that essentially represent a 3D model of the forest, usually taken from aircraft, but there's a bunch of different platforms possible. And we want to turn that into some kind of just GIS vector data set, some points in which each point represents an individual tree in a forest, and then those points have some collection of attributes associated with them that could represent things like the height of the tree, maybe the crown area of the tree, some of the basic biometrics that can help inform management decisions. So how are we going to get there? Well, we start with our LiDAR data, And then there's a process of raster generation, and then there's some vectors that we generate, there's a segmentation process, and then there's some post-processing. And one of the reasons why I wanted to talk about this today, and one of the things that I find interesting about this whole project, is that it works at the intersection of a whole collection of technologies that are all very sort of mutually beneficial. So there's GIS in here, and there's remote sensing. There's also machine learning and AI. There's, we make use of some of the high performance computing resources on campus that are a big help. There's some statistics, and then there's just plain GIS and the sort of applications that can be supported by that. So I'm just going to take you really quickly through the steps in this tool chain to try to describe a little bit the kinds of processes that we go through. So I wanted to touch briefly on the concept of LiDAR data and what's going on with LiDAR data. We've been using LiDAR for decades to look at information about land cover or the terrain surface. But of course that technology changes over time. And today, LiDAR is not all the same. You're not always going to get the same kinds of data density, fidelity of reproduction of the conditions on the ground from different LiDAR, combinations of LiDAR platforms and instruments. So I just have up here three practical examples. These are all LiDAR representations of the same tree that were collected with different LiDAR systems with different parameters, sometimes at different times. And so just to give a sense of the kinds of data that we work with. So on the left there, and hopefully you can see it, it's a little bit faint because the point cloud is so sparse. On the left there, that's that tree represented using 3-dep LiDAR data. So these are data that are freely available, provided by USGS. And they're primarily intended for in measuring landform, terrain and things like that. But they're also used quite a bit in forestry and other kinds of land cover analysis. So that in 3-dep, that tree is represented by about 400 points in the LiDAR. In the middle there, you see this is actually an airborne Geiger LiDAR sensor that was used to collect the data for the middle tree. The result is actually very similar to what you would get maybe with a UAV, a drone flying a LiDAR just a short distance above the canopy. We're looking at 15,000 points in that representation of the tree, and you begin to really be able to see the stem of that tree and be able to start differentiating some of the branch structure and some of the actual internal geometry of that tree. And then on the right, this is a ground-based LiDAR product. So this was actually a LiDAR that somebody walked around the forest in a backpack. And that tree is represented by about 1 million points in that data set. So there can be pretty big differences between different kinds of LiDAR data. And the process I'm going to walk through here is mostly dealing with data that's like the middle example here. Just really quick, there's a lot of tools that we use in this data processing chain. I'm not going to go in depth about all this stuff, but especially R and Python, and then ArcGIS comes in at the end. So the first step in our processing chain is raster generation. So what we do with these LiDAR data is we collapse them all into, instead of 3D models, we make them into 2D models. So we remove a lot of the dimensionality from them just to get products like this that show us, this is a canopy height model, which is, in sort of technical terms, is the digital surface model, which is all the stuff on the Earth, including the Earth, and then the digital terrain model, which is just the bare Earth surface, If we subtract those two, we wind up with this, the canopy height model, that shows us basically the heights of trees. And we take those data and we use them to develop a new set of clipping boundaries for our LiDAR data. LiDAR data tend to be pretty big files, and so they tend to come all broken up into little square tiles. And that's great for data transfer. It makes the files smaller and easier to move around. But one of the things that it can do is those tile boundaries are sort of arbitrarily drawn with respect to what's on the ground, and they can wind up cutting trees in half. So one of the things that we like to do is kind of adjust those tile boundaries using the canopy height model to try to direct those boundaries around the major area of trees, so that we can, when we process the data, we'll have a tree being entirely represented on one tile instead of split between two. And then we go through and put those LiDAR data through a segmentation process, which takes the whole point cloud, that whole 3D representation of what's on the Earth, and is able to separate out the points that it thinks belongs to individual trees and give them all unique identifiers. So now we've changed that point cloud that describes the whole landscape into a data collection that actually does represent individual trees and allows us to start making measurements on those trees. We can easily get the height and the crown width from these things, but we can possibly also get some other information that foresters are interested in, whether it be like crown volume or crown ratio or height to live crown, things that may not mean a lot to the whole audience here, but basically we're talking about how foresters think of the shape of trees and why those things might be important to them. One difficulty with all this is the segmenters aren't perfect. And they're going to produce artifacts, things that are not trees. And so we try in the beginning of this process to make a distinction between what we call objects and what we later call trees, because we wind up with this example I have on the right. This is a thing that a segmenter decided was all one tree. I can see probably at least 3 different stems in there, and 2 trees that are sort of tilting and fused or meshed together at the top. So that's not a tree. And then up above I have, sometimes the segmenters will pick out little bits of a tree crown and just have them floating by themselves up in the air. Or sometimes there's confusion with a shrub layer on the ground about whether we're getting shrub or other kinds of things down there. So after we go through that segmentation process, we have a labeling system that we can use where we can take a random sample of the objects that we classified or segmented out of the point cloud, and we can just sort of go through quickly and visually put those into a 3D viewer where we can kind of spin them around and take a look at them and see them in a little bit of context. We've got some scale bars and stuff on there. And in this case, do a really simple classification. This is a tree or this is not a tree. And we can have multiple people do that classification on these objects and gradually develop a pretty good understanding of which objects are trees and which aren't. And then we can use that labeled data set to do 2 things. One, we can feed it back into the AI segmenter as training data to improve future segmentation. The other thing that we can do is we can take the training data and train something like a logistic regression model that we can use to apply the sample classification to the whole population of trees or objects within our segmented data space, so that we can assign a probability that an object is a tree across the whole area rather than just within our sample. And in the end, we come up with a vector product that we can expose on ArcGIS Online, we can consume in ArcGIS Pro, and can be consumed by dashboards and support management decisions for forestry. So that was my quick coverage of that topic. There's a whole lot more that I could talk about, but and I'm happy to answer any questions, or my contact information is up there. Okay.
Okay. Thank you. So we may save the questions at the end of the this short talk session. So our next presenter is also from University of Idaho, Frederick Lattery. The presentation is titled Bead Leaf Hopper Abundance Interpretation, Classical Method versus Model-Based Approaches with Spatial and Spatial Temporal Evaluation. I think the presentation will be on Zoom. Hello. Okay. Thank you.
Hello.
Welcome. Hi.
Hello, everyone. My name is Ferishte. I'm a master student in water resource engineering at University of Idaho, and my work focuses on forecasting beach leaf hopper density in Washington State Central Basin. Before I talk about this insect, I want to explain why this matters. Worldwide, around 40% of crops are lost every year due to pest and disease. And these numbers represent a real economic stress on growers, because to deal with these losses, many growers rely more on pesticides, which are expensive, and also this is a threat to food security. So this is beach leaf hopper, and a small insect, which is common and widespread across the western US. And what makes it important is not just its feeding damage, it is a vector and transmits curly top viruses and BLTV phytoplasma to crops when it feeds. And in Columbia Basin, outbreaks of these insects can lead to 30% yield loss and reduce crop quality. The place that where this is really matter is Washington State Central Basin. This region has a semi-arid climate and one of the major potato growing areas in the United States. And if you look at the potato production by states, we're 1,065 acres of potatoes. So when the population of this insect rise here, the consequences are not small. So this shows that why this area is a critical region for evaluating this insect and forecasting the BLH abundance. So the main objective of a study is that we want to predict beach leaf hopper abundance across multiple locations in Washington Central Basin and across different times within the growing season. So here we are asking where and when population increases. But before going further, I want to explain a little about the concept of spatial stationary. Here is the global regression model, and as we can see, the relationship between variable is same everywhere in the region. So here it treats the entire map of its old field and it responds as the same way. So for the beach leaf hopper, because they are more highly mobile insect, this is not work here. And Another model is a geographically weighted regression model. This model allows changes relationship between variable to change from one location to another. And here the point is that the closer to the location we are modeling, are given more weight, and points that are further are given less weight. But here there is a problem that this one just focuses on a special neighborhood. There is another model which is spatial and temporal weighted regression. And this model is an extension of geographically weighted regression model. And here the idea is that it's borrow information from nearby location and also from nearby time stems. So it means that the observations that are closer in space and closer in time have a stronger influence. Based on these concepts, my research question is, first is that we want to ask whether including time actually improves our ability to forecast Beasley-Hopper abundance. And also, we want to compare the spatiotemporal weighted regression with another model like geographically weighted regression and global model in forecasting BLH abundance, and to see what is the optimized temporal bandwidth. But in this presentation, I want to focus more on the GIS part. The data that I used, first one, I had some independent variable, which were climate, and I got them from the package called Climate R, and from the GridMet dataset. The second one, dependent variable, or the trapped counts of this Beasley-Hopper, I get them from the Decision Potato 8 system of Washington State University. And for the vegetation index, I used from the Google Earth Engine and satellite Sentinel-2 images. So this one shows my independent variable. At first, I used number of 9 variables. And looking at the collinearity between them, there were some high correlation between some of the items, and I changed them with the average, like temperature minimum and maximum, relative humidity to minimum maximum, to solve this issue. And these are my dependent variable, and I have data from 2017 to 22. And DOI means that the number of weeks that data gathered each weekly from the growing season, and each year separately. And observed point means the number of locations that data gathered in this location. This is my vegetation index. I got this from the NDVI from the growing season. I just represent the 2019. And this is a Sentinel-2, and I used a cloud of less than 20% and a window of 5 day, and fill the gaps with seasonal NDVI. The reason that I use vegetation index is that when BLH infects the plant, disease symptoms appear with a delay. And I use the NDVI as a validation to my prediction to see what's happened when the plants are diseased, and how much the number of this encouraging interpolation that I use. I used the encouraging interpolation for each DOI for each week separately. And just as a bigger point, I wrote the last part. And as we can see, the interpolation, it seems a little patchy, not as smooth plot, and these dots are the location that the data gathered. And this is the prediction of using geographically weighted regression and spatial temporal weighted regression. So these are, let's patch here, they are smooth. And the reason is that geographically weighted regression consider this one considered the locations has an optimal bandwidth, so consider more location. But STWR or spatiotemporal weighted regression has a optimized bandwidth not only for location but also for time. It means that consider the locations that have coordinates in the past weeks that we have data. So, and looking at the R squared, the spatiotemporal weighted regression is around 68% in comparison with the just considering geographically weighted regression, which is 36%. So it's has a better outperformed the other models. And finally, for the future, I plan to compare this simple interpolation with other model, machine learning model like random forest and XGBoost. And also, because the BLH density changes across the space and time, our results show strong non-stationary, and we want to have this comparison to see which one has a better performance and better prediction and interpolation between the insects. And finally, I would like to thank my advisor, Dr. Johnny Lee, and also Dr. Zhu from the University of Idaho for their guidance and for their help. And thank you for your listening.
Okay. Thank you for two presenters. Fantastic, fascinating presentations. So we have time maybe for one or two quick questions for either of the two presentations. Any questions from the audience?
One back here. Yep.
This is a question for the digital forestry. I once tried to do something similar on my own, but I thought I think the LiDAR that I had was traditionally airborne from those tree qualities of LiDAR you put in. Do you think it's possible to get a similar product from that kind of LiDAR, even if it's just a single point of vector?
It's yes. To answer your question, from some of that more sparse airborne LiDAR, we can get a lot of pretty good products out. There are things that we can't see, right? We can't see below the canopy very well. Mm-hmm. There are some points down there, but they're not great. So we can find trees in the dominant canopy, and we can typically find those treetops, and we can delineate their crowns, so we can find a crown area. And so we get height and crown area and location, and then there's not a whole lot more that we can do from there. There are some other things, but with the vertically denser point clouds that you get from some of these other LiDARs, from platforms that are closer to the ground and other kinds of things, we do get the capability to deal more with some of the stuff that happens underneath the canopy top. So there's quite a ways that you can go just with the canopy top, but there's more stuff that you can do if you have more data.
Okay, thank you. I have one more question. Another question, just something I want to share. You know how you said that it's segmented, right? Well, I made a mistake of merging all of them together and then running the process, and that took forever, and it wasn't really good. So I was like, I probably need to not merge those points in.
Yeah, one of the biggest limitations for us in segmentation right now with our machine learning segmenter is video RAM. Mm-hmm. So the bigger we make a tile that we feed into the segmenter, the more video RAM it takes up. And so that's one of the reasons why we have to keep these to smaller footprints.
Yeah, and do you have any other resource someone can look to try to recreate it for their own use if it's possible?
We don't currently have any of this published, but it's on the way.
Okay.
We're working on setting up a GitHub repo to publish our code, and we're working on some papers. So yeah, we'll be getting the stuff out there.
All right, thank you.
All right, we're probably at time, I think, unless we, anybody online? No questions? All right, we probably ought to hold there. Let's thank our presenters one more time there. And we're going to take just a brief break while we get connected up with Idaho State University. We're going to do trivia next, so everybody hang on. We'll give this a try, and they're going to be running it from down there, so we'll be able to connect. But take a quick break, and then we'll have some instructions on that before heading into our last round of short talks.
There we go. Excellent. Hey, also, give me 1 second. I'm going to finish up what we're doing here, and we'll get you guys started. U of I hope you guys have been having a fabulous, amazing time with everything you guys have been doing. Thank you for the short talks earlier. Those were wonderful. Briefly, if I can be smart enough. Uh-oh. What technology? Wonderful. So this is to give you guys a quick idea of a kind of a sample question on the fun things that we're going to be going over here.
Hey, Heather, it's Bruce. We got your screen. Looks good. Folks are getting ready here, so thank you.
All right. We're going to see if I can get a PowerPoint display on this as well, because there are a couple of rules.
All right, folks here in Moscow, get your devices ready.
Yep. So a couple of quick works. This is done through an app called CrowdPer. I'll be bringing up QR codes. You don't have to download anything. You'll just be scanning it and entering it. When you guys enter in, you'll be entering a nickname, a name of whatever you want, and you'll be picking a team, either Pocatello or Moscow, depending on where you're located. So we will be not only looking at individual scores, we'll be looking at team scores as well.
Oh boy.
Oh yes.
Right.
We're going to do 1 5-question warm-up round. I will clear this out when it is done so the points do not carry forward. This is our quick test to make sure that everybody's able to get in as they're supposed to. Points are earned on accuracy and speed, so the correct answer, the fastest, gets the most points. We're going to try to run through 2 rounds, and we'll see if we get through all of them. 20 questions each, 30 seconds per question. In the main one, the warm-up is much shorter. There's a reason some of these, there's a 30-second timer on these. Just the question will appear. We'll read it out loud, give everybody a time to look at it, and then I will make the answers available. As soon as the answers appear on your device, you can start picking an answer.
Let me see if folks here are... has everybody got the QR code? Or okay.
Not yet.
Folks,
I'll get it in just a second.
Oh, I'm sorry.
Yep. No, you're good. Some questions have multiple answers. They'll have a select all that apply because I didn't realize you couldn't select multiple answers in this app. That's okay. It means there are at least 2 answers, maybe 3, but never all 4. There are no all of the above or none of the above options. Fun fact for those of you looking at the GISP exam, I hope this still holds true. It used to be that it would kind of cut you off with possible answers. So if you went to go select a 3rd option and it didn't let you, it meant there was only 2 possible answers. So that is a nice trick when you're taking the exam. Everything that is showing up on the actual rounds, not the warm-up, is material either pulled directly off of the old practice exam or the unofficial study guide available at the website on the screen. You guys are going to be able to tell real fast which answers are the ones I wrote, pulling off of the study guide, and how late it was when I wrote them. With that, we're going... Whoops. Yeah, let's see if I can get this to... So many windows. Not the right one. Where did my... Do the drag thing again. Where is it? Yeah, where does this thing keep going? I am not smarter than this device, and that is frustrating. Okay, there we go. And now it won't be up there.
Oh, you want to go there?
Yeah, that needs to go there. This for right now. We're going to go into this one, this one. This is what it should be saying. I hate this.
Oh, we fixed it.
Yeah, too. But technology. We love our technology.
You guys see it now?
There we go.
Yeah, we see your crowd per warm-up 2 there with the scan to join.
All right, cool. So I said these are just the warm-ups. They're pretty fast. Hopefully you guys will be able to get everything scanned in okay. Let's go ahead. All right. So our very first question. Legal descriptions reference a section, township, and range that are based on a meridian. In this context, what is a meridian? Okay, I'm getting answers, so at least some people are coming through. It needs the trash can up there. Yep. Next question. Related. Where is the Boise Meridian? Anybody who read legal descriptions out here, you will see section, township, range, Boise Meridian. Specifically, where is the monument for the Boise Meridian? Oh, watching answers come through. This is interesting. I like this. Yeah. If you were to follow Meridian Road south, about 15 miles south of Meridian, that's where the monument is located. So in fact, it was chosen for that location because it is one of the few spots where you can get a direct line that runs through from Idaho, from the north to the south border. This line will run all the way up to Canada. Okay, what is Idaho's official nickname? The real one. Idaho is known to about 72 different kinds of gemstones that you can go and find. Not all of them the best quality, but you can go and find them. All right. Mount Bora is Idaho's highest elevation point. Where's the lowest? Lewiston is also home to the most inland port. All right, related to an earlier question, we're the gem state. What is our official state gem? Next fun fact, the star garnet is only found in 2 places on Earth, northern Idaho and India. All right. AV, all right. Nobody here. All right, you guys are winning this one. Cool. All right, we're gonna have fun with this. I'm gonna clear this one out. These points don't carry forward. Sorry, you're all gonna have to relog in again because that's a thing. Because now the points start to matter. It'll be fine. All right. Here for a minute. All right, there is more target. Go. All right. I'll give you guys just a minute, get re-logged in. Good here. All right. Good luck.
Thanks,
All right. You want to create a data set of forested areas from remotely sensed data. Which of the following data source properties is the most critical? This is so much fun being on my side because I can watch answers as they start to come in. And I can kind of guess where some of y'all's background is based on where the answers are. As I can kind of guess backgrounds based on who is used to doing more like remote sensing type work versus those who probably have more of a biology background. Which of the following is true when using oblique imagery? Which is a limitation to consider regarding the use of UAS? I'm gonna throw it out there. This is not one of my questions because I actually kind of hate the verbiage. In Moscow, I don't remember if we were logged in or not when we had this discussion. For those of you who take the GISP exam, you are allowed to leave feedback on questions. I highly encourage you to do so because things like this, where like I hate the words that they used on this one, you can say something and enough people do, they will answer, they will fix it and replace the questions or reword them. So. Yeah. I do not like the verbiage on this question. This is, yep. Hey, open source data has the most limitations related to which of the following? Before I show the right answer on this one, because I can see what people are putting in. Some of y'all are gonna be really mad. And for those of you who are mad, I fully agree with you, by the way. Okay. When exchanging geospatial data from one software to another, which of the following is generally considered the best practice? There are multiple possible answers. This app will only let you select one of them, unfortunately, but there are more than one possible answers. I'm going to do a quick vote here because I'm realizing we're going through these a little slower than I thought they were. Is 30 seconds enough time, or can we take it down? Take it down? Moscow, what do you guys think? You want me to cut back the time to answer questions?
Moscow says 20 seconds?
All right.
I think.
What are some of the ways data can be collected in the field? This is another multiple possible answers. Very good. Kudos, not a single person chose archival records, by the way. Well done. Well done. Okay, what are some ways to achieve data generalization? Again, multiple possible answers. No one chose exaggeration, by the way. Okay, which of the following are vector formats? I intentionally didn't choose music for any of these because I hate the music that comes with them, but which of the following are raster formats? And there's another one with multiple answers. Questions like this are also fairly common on the GISP exam, where you'll maybe have a question you don't know the answer to, and then you'll get a couple more down the line, and it'll be a related question that you're like, oh, I know the answer to that one. I need to fix my answer on the other one. You can do that. All right. What are some components of a shapefile? Multiple options. You are creating a map at a municipal scale that can be roads and buildings overlaid on a municipal high-resolution imagery. The roads data layer is a national data set, and the buildings layer is derived from said imagery. The map displays roads that are offset and may intersect with the buildings. What should you do to improve the display of the layers on the map? The data layer needed for a GIS project is only available in a .dxf format. The limitation of using this data format within GIS. And I can't wait to see how you do, because I do not know the answer to this one. If I did not write this, I would have no clue. Which of the following statements is true in regards to XML files? Which of the following is not a limitation to consider when developing a UIS geospatial data project? Ooh, that one had a slow start. Y'all had to think about that. Which this is one I will admit, this question may be dated. I'm not sure how accurate that answer is anymore. You have a building layer. We're going to call it buildings because we're creative people. You want to create a selection of all buildings with a name starting with best hotel. You create an SQL statement with a where clause written as building name equal best hotel. The query returned are only 20 records. Based on your examination of the table, you know there should be more than that. Which of the following SQL query statements should you utilize in order to use the wildcard operator to improve your results? And if any of you have ever played Find the Missing Semicolon, you understand why these are written the way they are. Oh, see, and this is one, I apologize. I messed this up. I selected the wrong one. B is actually the correct answer. That is my apologies on that one. Oh, I know, I know. Like I said, feedback on answers are always good. Okay, earlier we asked, what are the components of a shapefile? Here it is again. Multiple answers possible. You know what? If I get through this entire thing and I only messed up one question, I'm going to count that as a good day. One of the fun things in the GSP, you are expected to know all 7 extensions for a shapefile, what they are, what they stand for, and what they do. They will ask questions about all of those. Similarly, what's a .dbf? This is one I pulled from the exam, not the exam, from the study guide. I get what they're going for. If anybody doesn't know, it literally stands for database file, is what DBF is. Okay. What is the ETL methodology of data integration? Which of the following are select by attribute options? If you're in your layer or your table and you select the little buttons, the select by attributes, there's some options you have in there. These are all available. There are multiple answers, but these are what you would get in the drop down, or not the drop down, the box that. I'm gonna be quiet now. Y'all can read. Okay, there's a picture on this one. I threw this question for a very specific reason. In this illustration, if you were to do a select by location, which of the following answers would be a false statement? You would return a 0 result, is what we're thinking. So you're either going to get 1 result or 0 results. Which of these would return a 0? Oh Oh, you guys are all over the board on this. I love it. There is no clear winner on the selection on this one. That is amazing. So Clementini specifically excludes boundaries. So there's within Clementini, and I think I don't remember what the other one contained, I think Clementini. The Clementini algorithm will specifically not count the boundaries. You know how many years it took me to figure that out? All right. That is round one. I realize that we are technically out of time. I don't know how locked in everybody is on times. We can call this, keep going for round two if we so desire. Very good. Got Nico. And then Nick. Very good. Nick must be at Moscow, I'm assuming.
I most certainly am.
All right, excellent.
There you go. You guys did good.
Yeah, that was great. Thank you very much. That was a... Which team won here? Oh, we don't know which team won, do we?
It doesn't give me
Or
the
is it-
team. I'm disappointed.
Oh, okay. Oh, well. That's awesome.
Yeah,
Thank you so much, Heather. That was great. Oh, wait, winning teams.
There we go. Is that second place?
Moscow.
You know what?
Go team.
For point wise, that's not bad.
Wow, that's
Not
close.
bad. All right, I'm gonna do one more.
Perfect. We're going to jump off because we got to start our short talks next.
Okay, give me 1 second just to throw something out there for you guys.
Okay.
Obviously, thank you to everybody who's done this. Participation is huge. If you like this, if you want to keep playing this game, if you want to do more things, the Gem State chapter of GPN, formerly ERISA, Intermountain GIS Conference is coming up in April. It is in Pocatello. You can look up Intermountain GIS Conference and find the website for that one. We have extended our call for presentations. We need presenters. It does not have to be directly about GIS. It can be related to GIS. If you are shy and don't want to do it, give me 5 minutes of something really cool. Like lightning talks are a thing. We need people because these don't work without people. Registration information will be up soon. You guys are going to get blasted with a million emails when things like that starts going up. But please share, please come, please present. Come and talk with us, come and play with us. We have a really good time. And if you're shy about presentations, this is some of the coolest people on the planet to present in front of. They're good practices. We need you here. So.
Awesome. Okay, everybody online in Moscow. We got to get there in April. Question back here. Thank you very much, Heather. Appreciate it.
You guys have a great day.
How do we get a hold of it? Yeah.
Oh, I can give you your email. Or do you need to go to the conference?
Well, I might present.
Okay. Yeah.
We can blast that out on the email list with the follow-up.
Yep. All right. Yeah, I think we're okay. Yeah, we're ready to start short talks, and going to let Josh take it from here. Thanks. Hope everybody had fun with trivia. Something different.
Sure. So thanks, everyone, for coming to UI's GIS Day. I'm Josh Conver. I'm the Bruce of Washington State. So I want to thank UI especially for bringing me on and letting us have this collaborative event. So thank you all for staying also to the afternoon. My first speaker is Eric Hildebrand from Avista. He's the CPC Wood Pole Management Group. So let's get you up and we'll get you on the laptop. Should go for you.
Okay, my name is Eric Hildebrand. I work for Avista. I'm a CPC in the wood pole management, and more specifically, I do what's called control zone mitigation. I'm just going to go through and kind of go through the design process and how we use GIS and what we use. A little bit of background on the control zone mitigation. What that is in Washington State, they made a requirement that objects and utilities and stuff need to be a certain distance off of traveled roadways, off of state highways. And so when we want to do our franchise, we need to go through and make sure that all of our poles and everything are outside of that control zone. So they have a book, or actually not even a book. It's more of chapters of what we go through and certain formulas and stuff that we have to use to determine what the distances are that we're going to be, you know, how far the distances need to be. So one of the first things we do is we determine the area that we're going to be working in. And on that, how we do that and using the GIS is we have a surveyor go out and he surveys where everything is, because it's important for us to know where everything is located so we can be more specific and be precise as to where everything needs to move. So when he goes out and gets his points, he brings them back in, I pull them in, and then I can see where the center line of the roads are, I can see where the poles are, I can see where everything is. Then when that's done, he gives it to the drafters, or we send it into the drafters, and then they make up what we call our plan and profiles, and they look like this. And so as you can see where the pole is, you can see where the fog line is, you can see where everything comes down, and then this tells us whether or not we're inside the control zone or if we're outside the control zone. This pole here is okay, so we don't need to do anything with that one. But if we do have a pole that needs to move, we also have a couple other different things that we need to do in the design process. One of them is avian protection. And so one of the things that we have that we put up, a layer that we need to turn on. Let's see if I can find it. Well, there it is. So we click on avian protection, and then the layer comes up, and you can tell inside this area that we have poles that need to have avian protection. And what that means is, as you can see on the little pop-up here, it says it's type 1. Everything's been moved to type 1. We used to have two types, one that was in the desert areas for avian that's in the desert, and also for waterways, and we decided that we're just going to straight 1, so everything's going to be the same if it's an avian protection area. So we need to make sure we have that on. Another layer that we have to turn on that's not on this one, but it's city, because if it's inside city limits, there's a different design criteria that we have to follow, and we follow the city criteria rather than following the state, because the city has control over that roadway in there. Then the other one is, it kind of correlates with what the two other people from Avista were talking about. We have what's called wildfire risk areas. And so they were talking about when the big wildfires happen because of the downed lines. So now what we have is this area is orange, so what I know that means it's a tier 2, so which means I know that I have to beef up the design. So which basically that means is if I have a crossing here, I either need to put fire wrap on it so it doesn't burn, or it needs to be a steel pole. It's kind of depending on what we have for that. So then we go through, and another one that we have that's not working right now that I wanted to show you as well is, which is part of the wood pole management, is wood pole inspection. So every so many years they go out and they inspect the poles. So we needed to know if the poles, even though they may not be in the control zone, or they're not part of the control zone project, we need to know if we need to change them out as well because they're a bad pole. Then we go through, then when that's done, I will go through and I will make the design. This one's a little bit easier to see. So on here you can see where these green dots are, those where the old poles were. And so I needed to move the poles, so I moved them. And how we used to do this was we just go out in the field and we use a tape and just tape them and tape it from the roadway and everything. It was kind of a real pain. So the nice thing is now that we have these surveyed points, we can put them in there and then we can just measure off of those points and so we get more accurate. So then what I'll do is I'll place a pole where it needs to go. And the nice thing about this too is so when I place the pole, it places everything that's on there. There's things in there where it will place the cross arms, it'll place the pins and everything, so that way when we want to put it out for construction, it has all the parts and pieces listed there, so it just continually goes through. So then after that's done, then what I do is I worked with the GIS department. Actually, I requested from the GIS department to make a where they could take these points, so we can select the points and we can transform them into northern and eastern points. So that way I can go put them in a handheld, then I can take the survey equipment out and I can physically place them in the world. So that way it makes it a lot easier to be able to do. Then once that's done, the surveyor goes back out and he surveys those points, and we kind of go through the whole process again, and then we know that it's ready to go. And so that is how we use the GIS to kind of do a grid hard, or with doing the control zone mitigation and be able to go through that. That's it. Thanks.
So we saw a live software demonstration. Now we're seeing a live login attempt. It's really exciting at this point in time.
All right. All right. Okay, so our next speaker is Ali Bean from WSU Crop and Soil Sciences. Ah, there you are. Come on up.
Great. Well, good afternoon, everyone. My name is Ali Bean, and it's a real honor to be here to present at GIS Days. I got my start with the Long-Term Agroecosystem Research Network from a former GIS Day presentation where Bruce Godfrey helped me put together a dashboard highlighting some of the producers in our area and trends that we could see in one location across a large network. So I'm happy to be here several years later showing you one of the other Esri tools that we use, which is story maps in this instance. So I'm a research associate at Washington State University, and in that capacity, I work with affiliates here at the University of Idaho and also with USDA LTAR is the acronym for that. I'll give you. And as an employee of Washington State University, I would like to say that we acknowledge that our locations statewide are on the homelands of Native peoples who have lived in this region for time immemorial. The university expresses its deepest respect and gratitude toward these original and current caretakers of the region. For those of you that aren't familiar with the LTAR network, we're comprised of now 19 sites around the country, both cropping lands and grazing lands. And these sites are specifically selected because of their long-term history of biophysical data. You can see that we're here up in the Pacific Northwest representing on behalf of this nationwide network what happens on the Palouse. The diversity of our network is pretty significant, though, and that creates a lot of opportunities and also some challenges, as you can imagine. So on the left, you can see the wide range of agroecosystems represented across the country. Like I said, everything from rangeland to corn systems, wheat systems, dairies, integrated crop, livestock operations, and specialty crops. And on the right, another piece that we use GIS heavily for is because our research spans multiple spatiotemporal scales from individual plant physiology and biomass production to field level management and whole ecosystems, even some global scale drivers. We're able to accomplish the work that we do through a variety of working groups, and this is an open invitation to any of you researchers who are interested in some of the work that USDA ARS does from water perspective or any other part of the field that you're interested in. We open our working groups to those outside of ARS, so we have quite a few University of Idaho affiliates and Washington State University, as well as universities across the country. And we compile these working groups, hundreds of people all over the country, through Basecamp as our project management tool, and quite a few Esri products as well. Through our working groups, we decide and agree on what we are going to measure, which I can imagine all of you experience some challenges with. We do that through data dictionaries, getting our jargon situated with common vocabularies so that we can look at metrics and indicators across the diversity of our systems. We're all gathered together under our one mission through our strategic plan, and that mission is to conduct I don't have it memorized, I should, to conduct long-term transdisciplinary networked research, to create innovative tools and practices and regionally tailored evidence-based knowledge supporting adaptable, resilient, and sustainable agriculture. So it is quite the charge that we have given ourselves. These are the 7 initiatives we have in our strategic plan, and I'd like to focus on the top one here, adoption. So I do have a degree in geography, but it's human geography. So I'm interested in the human dimensions of agriculture and water use, and we see that in the work that I do through adoption. Are our best management practices being communicated effectively to our stakeholders? And if so, how can we show that we are making an impact? I'll skip through some of these because I want to get to the engaging stakeholders and the adoptions of our solutions and innovations, which leads into the story map that we have. It's one of our most effective tools to be able to communicate the science that we're doing. So in our story map, it's quite extensive, and I'd like to be able to share the link with all of you so you can take a look at it, but I'm just going to highlight 5 pieces from our story map. And the reason that I wanted to do that is because we received a charge from our USDA national program leader to put together a tool that highlights all of our network accomplishments that you can see here, anything from data that was collected and shared across the network for water quality or quantity, our eddy flux towers, phenocams, all of the different types of ways that we have data, open access to those data. And we also put together a special issue in the Journal of Environmental Quality, all of the different sites around the country showing that work. But we wanted to use a story map because they allow us to tell complex stories in a way that makes sense to people, and given the diversity of the landscapes and research topics, story maps lets us tie all of these together visually instead of handing someone a technical report, right? They can engage through our story map. So this is just a screenshot on the left of the story map and how we broke things down to make it more user-friendly. We wanted this to be acceptable for policymakers to be able to navigate through and understand the whys, but also for scientists to use to understand the whats. So I'm also happy to share with you that the group that put together this story map received recently in July of 2025 the Network Impact Award, and that was in recognition of individual and group level accomplishments that enabled the network to advance a vision for sustainable intensification of U.S. agriculture, and that was shared throughout USDA on their Axon program. But that's because it was in response to a time-sensitive request to communicate how the network is accelerating innovation with producer-driven science. And the communication went to Office of National Programs, was vetted through the Office of Communications, and so the story map was really the best available science with the terminology and jargon that everyone wanted to use to share that same vision. So some of the 5 pieces I want to highlight are here. We talked about how do we do the science. This was a way where folks could see exactly boots on the ground what was happening. This is a map of all of our different sites, and one of those sites is the R.J. Cook Agronomy Farm. For those of you that don't know about it, I asked Sarah Olson in a presentation earlier today. It's an experimental location. We have a lot of long-term data sets, so if you're interested in collaborating, let us know. But it is a Washington State University farm launched in 2000 for direct seed cropping. Second piece on our story map is how we share the science and the data. This, again, on the left is just a screenshot from our story map, so I won't roll it through everything there for you. But all of our methods and standardized protocols are published. They have a DOI and are on protocols.io. We also use story maps, dashboards, and other visuals. And again, I said this story map has been shared with producers, land water managers, educators, and decision makers. The neat thing about the network at large, too, having one of the sites be the Cook Agronomy Farm, we're able to use us as a case study to show business as usual versus aspirational type of land management strategies. And we do that through a variety of data sets that I am going to, let's see. Oh, I jumped right past it. Things like Socrata, Ameriflux, phenocams. If any of those type of data interest you, please let's get in touch. And then fourth, how we are solving cropland challenges. If we want to engage stakeholders, we let them know that we co-produced the project from the beginning with stakeholders, so it's not something we just dreamed up in our silo. Then we were able to go out into the field, we were able to test those different types of management strategies, and because they're long-term sites across the entire country, we have real data that we can show with our producers and land managers. And so the Cook Agronomy Farm is highlighted and featured as a success story of working with our stakeholders and constituents to be able to relay those data to other sites around the country. And fifth, we have resources for our stakeholders. So another thing I like about story maps is you can embed maps. They can go directly to that particular site, but we can also embed some of our resources and they can go directly to videos or other tools that we may have. So the image on the left is just a screenshot from that But one thing I'm excited about that we've incorporated recently from the human dimension standpoint is people are always wondering, like, so what? How does this make a difference? Why should I care? They could listen to me or they could hear from the stakeholder directly. So embedded in the story map, we have a completely different Excel file where we have the name of a stakeholder, how they fit within the categorization of if they're cropland or grazing land, how long we've been working with them, and a quote that we've been approved to use for them, kind of as verification that they enjoy working with the system, and here's what they recommend. So you're getting feedback from your trusted messenger source, which we're able to do here, and update in real time because of story maps. So as things change and we need to remove it, it's done just like that, which is nice. And then finally, I would just like to say thank you to the group that helped put together the story map that's listed up here. And on the bottom right, you can see the network of over 200 researchers from across the country as part of the LTAR group. And we're really interested to collaborate further with you all. So thanks for the opportunity to be here, and happy to answer questions when the question time comes. So thank you.
Okay, our next presenter is Priya Basu from WSU's Entomology Department.
Hi everyone, good afternoon. Thank you for sticking along for the last of us who are still here. I am an entomologist. I know nothing about GIS other than how cool the maps look, and I have my collaborators who do it for me. So which is why this talk is going to be a little different, talking about how citizen scientists can actually help shape projects that rely on GIS, rely on landscape, and rely on mapping. And I really want to thank Josh for inviting me to this conference because this has been such a cool talk. I'm sorry I missed the first half because I teach today, but whatever I've heard so far, and especially the game, that was fun. It is a humbling experience to know how little I know. I should have taken a bathroom break. In any case, I am here to talk about the citizen science approach to mapping the bee nutrition landscape. So when we talk about bees, pollinators, think about any bee, native bees, honeybees, there are multiple stressors that are impacting bees. And this is a global problem. When you really think about it, it is poor nutrient change, diseases, pesticides, any and all working at the same time. So essentially, when you're thinking about any bee in the landscape, that bee at a time point is being exposed to multiple stressors at the same time. It could be poor nutrition, pesticide, and a disease, for example. We often say that no matter which stressor you're looking at, optimal nutrition might actually be the answer to a lot of our problems. Bees are just like what we are. We are what we eat. So in a sense, bees need access to a better forage habitat. And I often say that the three most important features of a bee's forage habitat are diverse bloom, staggered bloom, and of course, abundant bloom. Diverse, meaning that something or the other is constantly blooming in the landscape. And usually, this is going to be a diversity in the floral types. Bees consume pollen and nectar that they get from the flowers in the landscape. Pollen and nectar have a huge amounts of macro and micronutrients that naturally are enough to sustain bees. So if we have a diversity in the bloom, it would mean that the bees have access to diversity of macro and micronutrients. Staggered obviously meaning that we have plenty of forage in the landscape, but critically throughout the year. So something or the other is constantly blooming from, say, the last frost of the year to the first frost of the year. And abundant obviously means more the forage, better the nutrition availability. And I know that For us, as homeowners, necessarily providing an abundant forage may not always be enough. But I usually say that even one flowering pot matters, because you just don't know which bee is going to come to it during especially the hot, dry summer months. So what are we doing to help establish our understanding of the bee nutrition landscape? I know I only have 10 minutes today, so I'm not going to go into details of all of the databases that I'm doing, but I really wanted to just show you and highlight that how citizen scientists can truly help us do this. One of my good friends, Marta, she actually said that what's the point in having one cathedral project in life? Which is why I thought, why not make 3? So either I'll die first or I'll retire first, who knows? But here's to bee nutrition. So the first project that I started around 2017, 2018 is building a pollen nutrition database for all bee species in North America. The second database is a pollen phenology wheel or a pollen atlas project. And then the third one, as an offshoot, is a palynology database. I actually have 2 of my graduate students here today in the crowd who are participating in some ways in helping us build this database, and one of them actually has a chapter on this. So in other words, if you have questions, ask them. So what is phenology? I'm only going to talk about the Pollen Atlas project because this is also something that a part of it we've started new. So what is phenology? Think about beekeepers, conservationists, native bee researchers. We all want to know what is blooming. What are the plants for bees? How do I know what's available in the landscape? Especially when you're looking at it from a stakeholder perspective, beekeepers have to store their colonies in large numbers in certain areas as they move them around through the pollination cycle. So beekeepers are often looking for these ideal forage habitats as holding yards where they can keep their colonies for a little bit so that they get plenty of forage. Because we still need to be able to provide optimal nutrition for bees. And as I said, pollen and nectar are really good sources, the only natural sources for all of the macro and micronutrients that bees need. So essentially, understanding this nutrition habitat is really going to be our key in figuring out what is actually available in the landscape. So phenology wheels can be really good tools that we use as pollinator researchers to identify when and where certain plants are blooming. And having these key information resources, as a beekeeper, they can strategically move their colonies around and keep them in certain areas. As native bee researchers or conservationists, we know what's blooming in that landscape. What's the nutritional quality of that plant, and then what do we do about it? How do we know if it's enough to sustain the native bees in that landscape? So this project really has far-reaching long-term impacts for stakeholders, for conservationists, for researchers, for homeowners, but also for policymakers if we really want to go ahead and start thinking about building an ideal bee forage habitat. So we really want to know primarily what is in bloom, when is it blooming. We want to know the basic nutritional profile of those plants that are there in the landscape, and we want to follow it over a period of time because we also want to track the effects of climate change. So what if the bloom times are shifting? What if we are gaining plants? What if we are losing plants? What if there is a pollination mismatch because the bloom times are shifting? So these are some of the questions we can answer. Now, we are actually asking beekeepers to be our citizen scientists for this particular database project. For the other database that I'm doing, the pollen nutrition database across the US and Canada, anybody could actually be our citizen scientist as long as you're brave enough and patient enough to go collect pollen, hand collect pollen. So for this one particularly, we have our beekeepers who are signing up because we can get large sample volumes from each location in a shorter span of time. And honeybees are generalists. So if there is a flower blooming, there is a very high chance they will collect that pollen because their feeding range is quite generalist. So they are probably going to go to almost any plant that will bloom in that landscape. So what you're looking at right here are the pollen traps that we ship out to our citizen scientist beekeepers. These are very easy to use. You can just install them in the front of the honeybee colony. They are also cheap, especially if you're thinking about shipping out pollen traps to every citizen scientist who wants to sign up. So these plastic traps are about $20 to $25 on Amazon, depending on the discount of the day. But these are easy to use. Now, if a beekeeper already has an existing pollen trap, we are not picky. We ask them to use it because our main goal is to be able to collect that pollen and bring it back to the lab. So this is what we basically do. We have these pollen traps, we ship them out to the beekeepers, and then they are collecting pollen for us once a month if the beekeeper has signed up for multiple years, or twice a month if the beekeeper has signed up for 1 or 2 years. So we do it every month. Then we bring it back to the lab, and what you're looking at right now is what a typical mixed pollen load would look like. Different colors indicating different flower types from where those pollen grains came. And clearly, I need students for that. I'm running out of patience and my eyesight isn't that good anymore. This is what it looks like when you sit and color sort those individual colors. So we are weighing it, we are color sorting it, we are reweighing it. Otherwise, how would we know how much pollen has been brought back from which plant? Then we have been using a Pantone sheet because this is something that anybody can buy. It's not a fancy coloring code that only scientists have access to in research labs. You go to a store, pick up a Pantone sheet, come match the color. So that's what we are doing. We assign each pollen color to a particular Pantone ID. We then use a special technique of staining called acetolysis, which essentially strips off the outer pollen kit layer, and it makes those pollen features more accessible. And then we also have collaborators, depending on the funding, because we are sitting on thousands of samples across the US. So we then ship them a mixed pollen load. If we cannot identify something visually, we send it to them for further meta-barcoding. If nothing else, at least we want to come down to the genus level and see as many plants as we can identify. And then, of course, we go ahead and we are also looking at the proteins and the lipids of these pollen samples. So in one sort of citizen scientist effort, we can map what's blooming, when is it blooming, how much of that pollen is coming in to tell us which ones are major blooms, which ones are minor blooms, and then we are also creating these freely accessible sort of picture albums for anybody to be able to identify that pollen by themselves. And then we are also telling them what the nutrition quality is. So essentially, just to give you an idea of like a zoomed in version of what it really looks like, we have kind of done a lot of trial and method, and we've come down to this one white light that we got from Amazon, the same table lamp, the same bulb, and we make sure every student is working on these pollen samples under that light. So when we actually do assign the Pantone ID, we know that it's uniform across multiple students. And I have to tell you, it takes an army of students to get this done. It's tedious, it's long time, it's time-taking, but I have collaborators across the US who can help me up to a certain point with minimal training and minimal resources. If I had come up with something that might have taken shorter time but more resources, more funding, it would have been difficult to help recruit additional people on this project. So if you really can't make out where those pollen grains are in this Pantone ID sort of collage that I'm showing you, that's where they are. The students have gotten really well in matching that shade as close as possible. And then, of course, we acetylize the pollen, and then this is what those pollen grains look like. And I just wanted to show you some examples of the different floral types that we have. These pollens are really pretty, but they are also very different. So our initial hope is that if nothing else, family and then genus level, that's how far we'll go. But once more, 3 years from now, 5 years from now, 10 years from now, once we have enough information gathered, we've built our own database, it's going to get only easier and easier, faster, to actually start identifying more and more samples along the way. So, as a part of this National Phenology Wheel, I recently launched the Washington Pollen Atlas, which is sort of like, so my pollen atlases are regional. I started it from the Southeast region 3.5 years ago. Now we are focusing on the Pacific Northwest region. So as a part of that, we've launched the Washington Pollen Atlas. If you are in Idaho, you are still able to collect pollen samples for us. You don't have to be within the boundaries of Washington State because this is still going to feed into the regional pollen atlas. But that's what we've just started, and we are hoping to start collecting samples from next spring. So this is what our vision is for Phenology Week, and for obviously everybody in the crowd who's waiting to see where GIS comes into play. Maybe this slide is for you guys, so wake up. So this is what we are going to do. We are using those Pantone charts, assigning these colors to be able to create a pollen chart. And then we really want to create a website, a dynamic website. So suppose you are in this location right here, if you see my laser pointer, right smack middle of that location. You are seeing a native bee with a particular color pollen on its hind legs, or you might be a beekeeper, or you could be anybody curious about what bees are bringing in during this time of the year. So then you click. Either you're in this location itself or you're pretty close to the location. So you find that nearest place and you click on it. And you obviously are choosing a month in the year, which month you are currently in, and then you're choosing that month from that wheel. So then you go into that location and you find for that month, these are the different pollen colors that we found from that location or somewhere pretty close to that location. So you see a color that might be very similar to what you're thinking, and you click on it. And this is what it's going to show. What plant? Who collected it for us? What's the nutritional quality? What does that actually look like? And then as much information as we can, we are going to add it onto it. So with that, we are really hoping to revolutionize how we really know, what we really know about the bee nutrition landscape, ground truthing that data. I also have several citizen scientists through iNaturalist who are now across the Pacific Northwest region. They tell us what bee they find in what flower and what potentially that pollen color might be if they are able to identify accurately. So with that, we're really hoping that we can help not only make people aware about what the bee nutrition landscape is, but also we can build this together over the next many years to actually formulate actionable strategies to what an ideal habitat might look like. So thank you, Josh, for inviting me. Thank you to the organizers for having me here. And I guess I'll take questions at the end. Thank you all so much.
All right. Our next speaker is Robel Alimaheyu. Perfect. From the Chemical and Biological Engineering Department at the University of Idaho.
Good afternoon, everyone. I'm going to talk about the application of GIS on setting up our experiment. It's not much detail about the application of GIS, but it's how we use GIS in setting up our experiment. Then I'll walk you through the experiment and overall the objectives of the experiment. Then stay with me. I think most of you are familiar with this image. It is one of the fascinating images taken from the very nice, interesting Palouse dryland. And then as you all can see here, there is something special from other agricultural fields. Then let's try to define what's going on here regarding to the topography. Then let's define what the topography looks like here. And then it's exactly very complex topography. And then you can see here that there is a spatial variability in the color of the corpus. Then it's actually driven by the spatial heterogeneity in soil moisture. So the area is characterized by like complex topography and also spatial highly variable soil moistures. So saying this, let's try to be more specific. Then I would say that the area is really characterized by rolling hills, and also there is a visible color contrasts in the crop that you can see from the image. But when we say there is a rolling hill topography, and then what's this bringing is there is a highly variable soil moisture in the area, and then this variation is also leading to a variation in the crop production. Then when I try to be more technical, this complex topography is due to the uneven infiltration and also redistribution of moisture in the area. Then this is finally resulting into a localized zones of water stress, and then those localized zones of water stress are also leading to a shortage of production. So this is the basic reason that researchers are really interested on to come up with a solution. And then one of the motivations that our research team is doing is because of this just variability in the topography and then the moisture, then we are trying to come up with a solution. Then Professor Dev, who is a head of the chemical and biological engineering department, is doing a fascinating research, which is starting from developing a soil moisture sensors and also he's also coming up with a very fascinating solution for this. So, as I said, there is a variability in the crop production, and then how we are going to address that? We are going to use a soil amendment strategy, which is biochar. And then for those who are not familiar with biochar, biochar is one of the substances which is which is a char found from the a process called pyrolysis, which is burning of agricultural waste products under a high temperature in the absence of oxygen. So what we are trying to do is just amending our soils where we think there is a localized water stress, and also because we can't apply the biochar entirely uniformly in the area because it is very costly. So we are applying this precisely, which is basically about the precision agriculture. So the objective, one of our objectives is just evaluating if this biochar is really going to help us restoring the soil water holding capacity and also the nutrient holding capacity of the soil. So just this is the specific of the objective that we are trying to address. Then to do this, you might be wondering like, how is then GIS going to help us? So we are using GIS, as I said earlier, to set up our experiment units. Then I'll read to there later. But it's basically GIS is used to remove all the spatial variability in our experimental units. Then, in addition to this, as I said, we, as a research team, we are developing a soil moisture sensors which are very affordable for the society. Maybe if you guys are interested, you can read more about this in the U of I capacitive soil moisture sensors developed by Professor Dev's research team. Then we are also working on that, and we buried sensors into our field, which is around 135 sensors, and then to do this, we need to determine ahead where the sensors should be located. So, yeah, we need to optimize the location of the sensors. Then, to do this, I will share you guys some of the insights and also the evidences that we try to use as an baseline data to locate our sensors and also to determine the position of our experimental units. So as I said earlier, our objective is to determine the effect of biochar. So as much as possible, we try to be consistent in the location of the experimental units. Then for that, we need to be supported by GIS outputters. So this is one of the GIS outputters. Actually, I need to thank over here Dr. Carl, who is director of the Rangeland Research Center in U of I. He gave us a lateral flight data, and then after that, I used just some post-processing. And then, as you can see here, this is a streamline data, which literally tells you on, just gives you some insight on the hydrological distribution of the streamlines in the area. So we can define, or we can just determine where the experimental unit should be, just trying to be consistent in the density of the streamlines, because as you can see from the image, there are some areas where there is highly dense streamline, and also there are some areas where there is a very less dense streamline. So from this, we know that where our experimental units should be located. Then we will rid off all the hydrological variability in the experimental units, so that everything that we will measure will be the impact of biochar. Then the other thing is also the same thing. I'm going to thank to Dr. Carl, because he did a lighter flight before snow and then after snow, so that he helped us to determine, or to just map this spatial distribution of the snow depths. Then you can all see that it's really interesting and fascinating snow depths distribution map. And the dark blue color is telling us that in the north face of our research area, there is a high accumulation of snow, and also in the south, there is a less accumulation of snow. So we need to be consistent where our research experimental plots should be. Then from those all insiders that we have found, or we got from GIS, we will try to determine the location of our experimental units. Then I'll show you how we set up our experimental units. Then, well, integrating those all insiders that we have found from GIS, we try to be consistent in the location of our experimental units. As you can see here, I have 9 plots where I'm going to apply treatment, no treatment, and then later on I'll use just the output of the yield from this plots as an analysis data. But just you can see here, all are aligned in the same contour line, because we need to read off all the topographic effect and also the hydrological processes. So this is how we actually try to integrate the GIS to set up our experiment in our research team. But we are trying to expand this for the future using just AI for agriculture. We have a team called AI for agriculture. So we are trying to use all the GIS related data as an input, and also maybe our farmers will also use their coordinates. Then later on they will get a prescription map of the biochar, because as I said, it's really expensive to apply entirely in the area. Then just we are trying to develop a tool where they can enter their coordinate, and then finally they will get a prescription map telling them that, oh, you guys need to apply a biochar over here, not there, like that. So we are just trying to come up with that solution. Yeah, in addition to this, I just need to share you something different, which I have done during my academic journey. And then it was a class project, actually. It was analysis of the landslide that has happened in 2017 in Switzerland, Bonda Sangalo, because I studied my master's in ETH Zurich, and then I got a chance to just do some research on that, to just give you a flavor of what I have done at that. So one of the things that makes me fascinated on GIS is, as you can see here, that I have a topo map in 1992 and 2020. Then we kind of did just digitization stuff on the topo map. First we georeferenced it and digitized it. Then what you see in the 1992 topo map is there is a map that shows you an area covered by a glacier, and also in 2020 there is a respective map that's showing you how the glacier area looks like. So I did the area calculation for those 2 years. The red polygon inside those two is the non-glaciated area, and then I think something comes up to your mind, hopefully, when you see this image. What's happening over here is a kind of global warming is really melting our glaciers. So it was one of the results that I have found and really makes me interested on keeping doing on things on GIS. So just this is the area discrepancy between 1992 and 2020, and I tried to come up even with how much volume is really lost due to the global warming, and then I did a raster calculation over that. Then I found it around 0.028 kilometer cubed water or glacier is melted. And then this is just to share you what I have done during my academic journey. Thank you for listening. And if you have any question, you can just reach out to me later. Thank you. Thank you so much.
Thank you. And then our last presenter for the day is Waylon Chen from the University of Idaho's Computer Science Department.
So good afternoon, everyone. My name is Waylon Chen, and I'm a PhD student in Computer Science Department at University of Idaho. And my topic is Fusing Domain Knowledge, Large Language Models, and GIS, a new framework from the mineral perspective. And critical mineral now is a global concern. And even though I'm now a PhD student in computer science, I got my bachelor and master degree in geology. So my research area and my research motivation is combine minerals and AI. From the U.S. Department of Energy, AI tools speed up critical mineral hunt, boosting U.S. supply. And my research question is that AI can do data mining, but can AI do mining? So with these questions, I pick a kind of AI named Neural Symbolic AI. Neural Symbolic AI combines the strengths of symbolic reasoning with the power of neural networks. It means we can use the knowledge rules and with the AI to guide the AI and do the stuffs. At the beginning, I can use the Neural Symbolic AI to do the mineral exploration exactly, because mineral exploration is it is expensive and it needs the firework. So I start with the mineral prediction. Mineral prediction is at the very early stage of mineral exploration, and it can help us to do the mineral exploration jobs. And here is the applications of AI in geoscience. We can see that machine learning and deep learning already applied across all domains in geoscience. But Neural Symbolic AI application remain limited. And at that time, I'm thinking why it is limited. Is it hard or it is not useful? So with these questions, I found the data set from the USGS, NIMS National Geochemical Database. And many thanks to USGS, it supports all the data I need for my entire PhD research. Yeah. And here is the framework of my first example. NIMS rule-based Neural Symbolic AI implementation. There are 3 target class. The data is labeled geochemical data. And the target class 1 is machine learning models only. The target class 2 is rule guide Neural Symbolic AI model. And the class 3 is external rule guide. The difference between class 2 and class 3 is that from the model setup, we just embedding kind of rules from the geological textbook. And the rule guide 1 got 4 rules, and the external rule guides got 14 rules, which means external, yeah. And here is the evaluation metrics. It is pretty similar in computer science. And here is the performance result. For the result, we can see that from model 1, the baseline machine learning model, to the rule guide model, and for the external rule guide model, the accuracy is increased. and the micro F1 increase for the minority deposit type. So we confirm that neural symbolic AI is useful for this task, but manually rules extractuation is a bottleneck, because I just show you that all of the rules embedding was embedding by me. After I read the textbook, I summarize it and evaluate to the expert, then I can get the rules. So my next goal for the example 2 is to make neural symbolic AI scalable, adaptable, and less reliant on human interactions. With this goal, and thanks for the development of the large language models, now we can use large language model to assist me to do this knowledge embedding task. The first part is from the deposit textbook. We use large language model to extract the domain knowledge. Then use the large model to assist to calculate the similarity from the textbook and the data set. So here is how the textbook looks like. It is a book named Mineral Deposit Models. Here is a PDF version. Since it is a very old book, there are maybe some mistake in the words or in the sentence. But we use an OCR technology to extract the words and use multiple AI agent to make the PDF to a JSON file. And a JSON file is a machine readable file that the machine can read it directly. Here is the entire framework of the example 2. One is the rules, another is the data. After large language model system matching, we got each data set samples with a label from the textbook. Then after training, we can get the outputs. The entire process has no human interaction. And here is the performance result. Here is the baseline model. The performance is 0.875. Here is the dropping test, which means I only use the knowledge, not the geochemical data, to predict the label. 67.8. What is interesting is here, some labels got high performance in the baseline model, and others they are not similar, because here you can see here is like some got 0, but here got many high. And combine these two, we got the performance of the neural symbolic AI. It is nearly 0.98. And here answer the questions with the neural symbolic AI can really help us to do the mineral exploration job. And here is a feature importance figure to show how the knowledge feature means K feature play an important role in the entire prediction process. So we now confirm the value of embedding expert geological rules into the workflow. So next part is the practical implementation. Here is the top 10 deposit name by record count, which means it got value latitude and longitude. And here is where I use the GIS system. I have no idea of GIS, but in the Q&A section, I got 918 points. I think it's a little bit higher than the average, yeah, I think. And I choose the top one deposit, which means Como. I don't know how to spell it, but it is in Idaho. And here is how I put the geological map in the Google map, maybe. Here is Idaho, and it is a little at the right top of Boise. And here is my research area. And this map is a little bit different in the color, because I can't use the color type exactly the USGS use, because this is regenerated by me. So I just use something to replace. And here is got some blue point. Here is, you can see my mouse, maybe not. It's at the bottom, left bottom. The blue one, the point. Even we got more than 10,000 of records, it only got 64 individual latitude and longitudes. So here is the result at the very beginning. We can see the potential of copper is separate. And for some faults of the geological map, there are still got high copper potential. This is not real because it didn't follow the rules of geology. Yeah. Then we just embedding the 3 kinds of rules. One is the same rules from the 87 deposit type from the textbook. The second one is the rock type in the geological map, which means different rock type may have different potential for different mineral. And the third one is the faults. Like in the fault, some faults can help to do some mineralization and somehow not. And the fourth one is the radiation of different kinds of elements. After implement these 4 kinds of rules, we see that now it just follow much more in geology. And we can see the copper potential in the middle of the map. And based on this prediction, we also do a molybdenum potential of the map. It is pretty similar to the copper one. And combine these two, we do a copper and molybdenum perspective index map. The yellow one is the highest potential. We can find the place of this entire area, which area has the most highly potential. And I'm working now, and I may need more validation. And so now I can answer the questions. AI can do data mining, and with neurosymbolic AI can support mineral mining. Yeah. And at last, thank you for your attention. Yeah.
So we have gone a little over our time. We'll take questions. If you would like to excuse yourself, please feel free. No judgment. I'm going to exercise some privilege. I have a question for Waylon. On these slides that you showed at the very end here, what is the resolution of this cell? What's that spatial dimension? Because I was looking at for this example, this copper one, right? Right here. How big is that area? Is that worth actually going out to mine, or what? So what's the size of the area that you're looking at that you found?
I don't know what exactly the file, how large it is, because the potential is based on the collecting points, and the entire potential we can calculate by the the control point, which you make more control point, we can more specifically the area. Okay. So if you want to know how large is the area, we can calculate it. Yeah.
Okay. Thank you. Other questions for anybody?
Online or in the room? I had one real quick, just for Allie. Oh, there you go. It looked like your story map team was pretty good size. And I've seen that in other presentations where organizations put together teams. Could you talk just a little bit about the people involved and the roles they played and how you broke up the work?
Yeah, thank you for that. So of those different working groups that I was describing, we definitely needed a data manager on our team. So that was Nicole Kaplan. She's based out of University in Fort Collins. Also, we had our LTAR network coordinator, and she was overseeing all the different components and pieces. And then of those different groups, we had representatives from our phenology group, our common experiment working group, myself from our human dimensions team. We did get collaboration from J.D. Wolfhorst, who's a rural sociologist who was here at University of Idaho and has since gone to Miami University. And then our national program leadership as well. So we had a lot of different hands involved in that. But what is nice is that we're learning how to use AI and large language models to populate something as simple as an Excel sheet that our scientists are familiar with working in, and they can just plug in the data, and then we can extrapolate that into a little bit more of a story, and then we can then put that into the story map. So it goes through quite a bit of different iterations there. And then, of course, someone on our communication strategy team to make sure everything got approved through Office of Communications. And, of course, Bruce Godfrey was a helper that I'd ask for assistance on the side.
All right, any other questions in the room or online before we probably wrap this event up? That sounds like it. All right, so with that, concludes GIS Day 2025. So thank you everyone online, wherever you joined us from, and thank you everyone who attended in person. Grab a cookie or a slice of pizza for the road if you're driving, or if you're just walking, do the same. And we look forward to seeing you next year, and hope everybody enjoyed the day. Thank you.